Welcome to goclasses. Please tell me, audio, video, volume, is everything clear? Is everything fine? Please tell me. Please let me know. So in this session, we will see the summary of set theory. Basically, particularly, we will see the summary of set. All the concepts related to set, we will see their summary, and we will solve the gate questions of set. So this is our target for this lecture. Okay. Now, so before we start, you can let me know, is the audio, video, volume, is everything clear? Let me know. Then we can start. So, okay, let's start now. So let me introduce myself. My name is Deepak Poonia, and I have done my master's from the Indian Institute of Science, IISc Bangalore, and many times I have secured top All India rank in the GATE exam, like All India rank 53, 67, 206, and so on. And before we start, let me tell you that the complete discrete mathematics course is freely available on the goclasses website for all the students. So if you want to study the discrete mathematics complete course, you can go to goclasses website and you can study for free. Okay, it is free for all the students. Now let's start. And before that, I want to tell you that we are going through all the GATE questions. Basically, for all the subjects, we are going through the revision. We are doing the revision and GATE PYQ solution, GATE question solution. This is our basically right now this course is going on. GATE PYQ video solution course is going on the goclasses YouTube channel. So either you can follow this course through YouTube channel, or if you want it at single place, okay, if you want all the subjects in a single folder, so basically this course you can follow this GATE PYQ video solution course plus revision course, okay, because we are also doing the revision summary, revision plus summary. So if you want to follow this, then you can just go to goclasses website. So this is the first step. Go to goclasses website. Okay, let me tell you the step number one. Step number one is go to goclasses website. Step number two is login. Step number two. So step number one, go to goclasses website. This goclasses website you visit. And the step number two is sign up. You can do sign up for free, or you can do login if you have already created account. This is free, of course. Okay, so you can create account for free. And also after that, you can go to my courses. This is your third step. Just go to my courses, and after that you will see this. This is this course you will see. What you will see? You will see this GATE PYQ course. Okay, so you will see this GATE PYQ solution course. In this course, let me tell you all the subjects you will find. Right now, operating system you will find and discrete mathematics you will find. But after some days, after few days, you will find all the remaining subject like theory of computation, computer organization, computer network, compiler design, digital logic, and so on. Okay. So this is the step. These are the steps you can follow to basically stay on the track with this course. As I told you, this course is going on in the goclasses GATE PYQ video solution course plus summary plus revision. Okay, this course is going on, so you can track this course for free. This is free for all the students. You can download all the notes. See, many students they comment that where can we find the notes, all the annotated notes, where can we find? So you can find all the notes here, all the videos here in a sequence. So these are the steps you need to follow to stay in touch with this course. Okay, to stay on track with this course. And also, if you are a GATE 2024 aspirant, if you are preparing for GATE 2024, then you can join our complete course, GATE 2024 complete course you can join, and you will get 3 months of extra validity, but you have to enroll in the next 15 days. Okay, within December month, you have to enroll. So if you enroll in the next 15 days, then definitely what you will get 3 months of extra access. So basically you will get 15 months of validity on this course. So you can enroll right now and you can start your preparation of GATE 2024. Similarly, for the GATE 2025, those students who are in the first year or second year, if you are preparing for GATE 2025, then you can join our GATE 2025 complete course. Again, you will get 3 months of extra validity if you join in the next 15 days. In the month of December, if you join, then you will get 3 months of extra access. Okay, so let's start now. First, we will see summary. The summary of set. Okay, so this summary, let's see set basics. We will see the basic concepts of set. Quickly, let's see. I will go very quickly because this set concept is very simple, and as I told you, this is a summary lecture. I will not go into the details. I will not tell you the proof. Okay, so we will not discuss the proof. I will just go through all the concepts, all the terminology, every important result, basically everything I will go through. In this set theory, as I told you, in the set, whatever concepts are there, whatever results are there, every important point that is there, okay, I will go through it. So let's see this summary of set. First, what is the definition of set? The definition of set is very simple. Set is a collection, and in a collection you can easily see set is a collection, and very important thing that it is an unordered collection, so order of elements does not matter. Okay, elements are unordered, order of elements does not matter. And also you can see distinct objects, all the objects are distinct, means repetition is not allowed, or I can say we will ignore the repetitions. Okay, so remember, set is a collection of, this is a collection of unordered distinct elements. These elements can be anything. What is the notation? What is the notation we use for set? For the set, we use the notation where we put all the elements in the curly braces and they are separated by the comma. Okay, so this is what we do. All the elements that you have in this collection, you put them in curly braces and separate by comma. So let's take example. See, you can see this example. This is a set in which you have 3 elements. There is a cat, there is a puppy, and there is another, whatever, this is another puppy. So you can notice there is a cat and 2 dogs. So this is a set in which you have 3 elements, and you can notice all the elements, these are the elements, these are separated by comma, and these elements we put in the curly braces. So this is how we represent a set. Okay, so very simple. Set is an unordered collection of distinct elements, means the elements cannot repeat. Like here you can notice there are 3 distinct elements, 3 different elements. We put them in a curly braces and we separate them by comma. This is another set in which you have 4 elements. You can check all the 4 elements are different. So for this set, the cardinality is 4 because there are 4 elements in this set. So we say that cardinality is 4. Okay, cardinality of a finite set. This is a finite set because only 4 elements are there. So this is a finite set. Cardinality of a finite set is number of elements in that set. So you can see these are the elements. This is element, 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 element. So there are total 4 elements in this set. They are separated by comma and we put them in the curly braces. This is the notation. This is the set notation. Now let's see this. As I told you that in a set, order does not matter. So this set is exactly same as this set because order does not matter. In this set also you have the same 3 elements. Those same 3 elements you have here. So remember, in these 2 set, in this set, you have the exactly same elements, exactly same number of elements. So these 2 set are basically same. Order does not matter. In which order you put these elements, that does not matter. You can put the apple here, you can put the apple here, that does not matter because set is a collection of unordered elements. So you can see these 2 sets are basically same because order does not matter. So unordered, as I told you, this is an important point. Another point, you can see these 2 sets are same because set is collection of unordered elements. Next, you can see these 2 sets are same because we ignore the duplicate. Duplicate is not allowed. Okay, remember, set cannot contain duplicates. So these duplicate elements that you have, these are ignored. You can ignore them. So basically this set and this set are basically same. Remember, these 2 sets are same. So here one point I want to ask, if I give you this set, what is the cardinality? What is the cardinality of this set? For this set, how many elements are there? Tell me. In this set, how many elements? I have given you a set in which you have some elements. How many elements you have? In this set, total how many elements? So you can see in this set total only 4 elements we have. Remember, we have, because as I told you, we ignore the duplicate. Duplicates are not allowed. This set is at this set and this set, they are basically same. So this set is exactly same as this set because we ignore the elements. So number of elements is only 4. And this number of elements in a finite set, this is called cardinality. So the cardinality of this set, that is basically 4. For this set, the cardinality is 4. Now let's move on. You can see these two sets are same because duplicates do not matter. Set is a collection of distinct elements. So duplicates we ignore. All these duplicates you can ignore. Okay, so these two sets are basically same, and the cardinality of this set is 2. Remember, only 2 elements we have in this set. Now let's move on. These two sets are same. In this set, only 2 elements you have. Ignore the duplicates. We ignore the duplicates. Duplicates do not matter. Now let's see. So the next is, you can see, so ultimately you can see that this is a set. In this set you have total 4 elements. The cardinality of this set is 4. Now you can easily see that if I give you, for example, look at this set. I give you 1, 2, A, B. In this set you can notice A belongs to this set. You see, set is a collection. You can consider this as a set, or you can call it a collection. Now set is a collection. So this is your set. This curly braces, remember, within the curly braces, everything that is a element. So you can see this is element. Okay, clear? So this is element. So let's call this set S. So I can say this is element of S. Okay, so that is the reason I can say this one. If you look at this one, this belongs to S. So this symbol we use, it means belongs to. It means belongs to. So this symbol means belongs to. Means 1 belongs to this set. 1 is in this collection. You can easily see 3 does not belong to this set. We don't have 3 in this collection. We don't have C in this collection. We don't have John in this collection. So these things we do not have in this collection. But you can notice B is in this collection. Similarly, you can notice that this element belongs to this collection, belongs to this set, because you can notice this is already an element in this set. So this symbol means an element of, or I can say belongs to. So this is an element of this set. Now let's move on. You can check that this is not element of this set. So basically it means does not belong to, is not element of. This is not element of. Now, so this symbol means element of. Now as you can see, this girl is the element of this set because this girl belongs to this set. But you can notice this dog does not belong to this set. Okay, so I can say this dog does not belong to this set and this girl belongs to this set. Now let's move on. So finally, we understood that some element can belong to the set or it may not belong to the set. So you can easily see. Now, very important thing I want to tell you, this is important, that if you have a set S, if you have some collection S, set means this is some collection. In this collection you have some elements, those are separated by the comma. Some elements you have. Now for any element, for anything, for any A. Now this A can be anything, remember. This A can be any element. So for any A, only 2 possibilities are there. What are the possibilities? Either this will belong to this set, either this is an element of this set. In this collection, either this A is element, or what can happen? This is not an element, right? Either this is element of this set or this is not element of this set. Either this will happen, very important, that either this will happen or this will happen, but not both. Okay, it cannot happen that this A belongs to the set also, it does not belong to the set also, but not both. So this is a simple point I want to tell you, that it cannot happen that both of them are true. Okay, so if this happens, let me assume this happens, that A belongs to the set and A does not belong to the set. A belongs to the set and A does not belong to the set. This type of situation is called paradox. This type of situation is called paradox because it simply means that A is here also and A is not here. So this type of situation is called paradox, remember, or you can say this type of situation you can call contradiction. So ultimately I am saying that whatever A you take, for any A this will happen, that either it will belong to the set, either it will be element of this set, or it will not be element of this set, but not both. It cannot happen that both of them are happening together. If both of them happen together, means it is element also, it is not element also. That is called paradox, or you can say contradiction. Okay. Now let's see. Graph theory revision and summary, graph theory summary lecture and PYQ we will discuss very soon. In the next, I think in the next 4 or 5 days we will discuss. Okay, let's see this. So as I told you, there are two type of set. One is finite set, another is infinite set. Infinite set means infinite number of elements. Finite set means finite number of elements. This is a set in which you have 4 elements. So this is a finite set. And this is a set in which you have infinite number of elements. So this is a infinite set. So there are two type of set. Now you can see what is the cardinality of a finite set. Cardinality of a finite set, remember, cardinality of a finite set, that is number of elements. How many elements we have in this set? So cardinality of a finite set is the number of elements in that set. So and we denote by this symbol. This is the symbol we use. This symbol means what this means? This means cardinality of S. Cardinality of set S. So if S is a set, then we denote cardinality as cardinality of S. For example, for this set, this is a set in which you have two elements. These are the two elements. This is an element, this is an element. So the cardinality of this set, you can see cardinality is 2. For this set, the cardinality is 3. Repetition does not matter. For this set, look at this set, the cardinality is 3 because this is element, this is element, this is element. Okay. You can notice that every element is also a set. So you can easily see this is our set. For this set, the cardinality is 3 because there are 3 elements. Element 1, element 2, element 3. Every element is a set. Like this element is a set, this element is a set, this element is a set, and that is fine. There is no problem. Okay, element can be set or element can be simple. No problem. Now, so this is the concept of cardinality. What about this? Are they same? Are they same? Are these two objects equal? Look at these two objects and tell me, are they equal? So the answer is no. See, this is a number, right? This is a number. This is not a collection. This is a number. This is not a collection. This is not a collection. This is not a set. This is a number. Number 1. But this is a set. This is a set which contains number 1. Okay, so this is a collection. This is a box. You can think that this is a box. This is a collection containing one element. Containing one element. There is one element in this set. Okay, and that containing one element, and that element is 1. Containing one element and that element is 1. So remember, you can think that this is a simple number, and you can think that this as a box. You can think that there is a box. In this box there is this one. So remember, these two things are not same. So you can think this set as a box. You can think this set, you can think as a box. In this box you have 1. So these two things are not same. Remember, they are not same, as I told you. So this is just a simple number, and this is a set which contains this number. Now, as I told you, set, you can think about set as a box. Now you can notice, if your box is empty, if there is no element, then it will be called empty set. Empty set means a set without any elements. So there are no elements. This type of set we call empty set. So if your box is empty, remember, if your set is empty, this is your set. This is your set. Okay, you can think of it as a box. In this box there is no element. So this type of, okay, I can say it is like empty box. In this box there is no element in this, and this is your empty set. This is a set which is empty. So you can see there is no element, and we denote this thing, we denote by this symbol phi. So this symbol we call it phi, and what it means, it simply means that empty set. Okay, so this empty set, this empty box we denote by the symbol phi. Now let's move on. So empty set means there is no element in this set. Okay, that is called empty set. Like for example, the set of all humans whose weight is at least 8 tons. How many elements are there in this collection? Tell me, how many elements? The set of all humans whose weight is at least 8 tons. So of course that is an empty set, right? There is no element in this. There is no human being whose weight is 8 ton, means 8,000 kilogram. Of course, there is no element. Okay. Now let's move on. So let's check it out. So are these two same? Look at these two objects. Are these two objects same? These two objects, are they equal? The answer is again no, because they are not same. You can notice that this is your empty box. This is empty box in which there is no element. This is a box in which you have empty box. This is a box in which you have empty box. Okay, are you getting my point? So these two are not same. So remember, this is empty set. This is your empty set. But remember, this is not empty set. This is a set. This is not empty. This set is not empty set. In this set you have one element. This element you have in this set. In this set there is a one element. Remember, this set is not empty. So these two things are not equal. As I told you, this is an empty set. So in this box there is nothing. In this box you have another box. Okay. So as I told you, no element is equal to a set containing this element. So this x, if this x, so this x is not equal to set containing x. As you can notice, no object x is equal to the set containing x. So this is something important. Now let's move on. What are the set representations? How many ways you can represent a set? There are many ways. For example, you can list all the elements. Like for example, this is list representation. You are listing all the elements. Like in your, this is a set, set S. So in this set, yes, you have total 4 elements. This is element, this is element, this is element, this is element. You are listing all the elements. This is called list. List means all the elements you list. For example, this is a list. Okay, for example, I can say this is list representation of, this is the list representation. You are listing all the elements. All the elements you are writing, like which elements you have. Okay, you are giving their explicit notation. You are giving their explicit representation. Every element you are telling that in this set you have 1, you have 2, you have 3, you have 4, 5, 6 and 99. You don't have 100, you don't have 0, you don't have -1. Now let's see. This is called Venn diagram representation. This is another representation which is called Venn diagram representation. As I told you, this is another representation. This is very simple, that basically just make a box. This is, I can say, more friendly, right? This is more understandable. Okay, like even if you show this to any person, so they can also understand it. So this is more understandable. Okay, this, it is very user friendly, I can say. Okay, so this Venn diagram, that you have total 4 elements. This is element, this is element, element, element. So there are 4 elements. Now there is another representation, that is set builder notation. It simply means that some property you are satisfying. Okay, some property you satisfy. This is called set builder notation. In the set builder notation, you say that we have those elements who will satisfy this property. Some property they must satisfy. So all those elements we have in this set who will satisfy this property. Some property we will write here. Okay, all those elements who satisfy this property are in this set, Okay, so this is your set builder notation. As you can see in this example, we have all those n, the set of all n. Remember, the set of all n, such that this property is satisfied, such that n is a natural number and n is even. N is a natural number and n is even. So you can see your set will be 0, 2, 4, 6. Now you might be thinking, sir, 0 is not a natural number. Let me tell you that some people, they think, they assume, some authors, some mathematician, they assume that 0 is natural number. Some mathematicians, there are some mathematicians who don't take 0 as a natural number. So it is your choice. Okay, if you don't include this, no problem. In the GATE exam, you don't have to worry about it. In the GATE exam, it will be given. If your answer depends on it, if your answer will change because of this 0, whether you take 0 in the natural number or you don't take 0 in the natural number, if your answer depends on that, then it will be given in the question. So do not worry about it. Okay, if you don't want this 0 in the natural number, then you can remove it, no problem. Okay, but remember, don't worry about it. Okay, some mathematicians, they consider 0 as a natural number. Many mathematicians, they don't consider 0 as a natural number. Now let's see. So this is your set builder notation, that all those elements who will satisfy this property. Okay, so this is an infinite set, because you are saying that all those elements who are real number and who are less than 137. So of course this is an infinite set, all the real numbers which are less than 137. Here you have basically n is a power of 2, all the numbers which are power of 2. Okay, this is a set which contains all the US currency, and this is set which contains all the legal Java program. So and so on. So very simple, you can check. For example, look at this set. This set says that those elements who are in natural number and who is less than 3. So you can notice, if you don't want 0 in the natural number, you can remove it, no problem. Okay, you can, if you want 0, if you think that 0 belongs to the natural number, then you can take it. If you don't think that 0 does not, if you think 0 does not belong to natural number, then you can remove it. It does not matter. Okay. So this is another notation. As you can notice, those elements who will satisfy this property, or I can say those elements who belong to some set and they satisfy this property. As you can notice, those elements which belong to set of natural number who are less than 3. Okay, those numbers who belong to set of real number who are less than 3. So basically in this set you have all the real number less than 3. Okay, in this set what you have all the real number which are less than 3. So all the real number which are less than 3. So this is your set. Now let's move on. Let's see this. Tell me the answer for this question quickly. Very quickly tell me the answer. What is the cardinality of empty set? In the empty set means there is no element. What is the cardinality of this empty set? For this empty set, what is the cardinality? How many elements are there in this set? In this set, there is no element, so the cardinality will be 0. So the cardinality of empty set, that will be 0. Okay. Now the next you can notice what is the cardinality of this set. This set is saying that those elements which belong to natural number, all those elements which belong to the natural number and who are greater than -2, less than 5. So what is this set? This set is basically asking cardinality of this set. Okay, the set is basically like, I can say -1, 0, 1, 2, 3, 4. So how many elements are there in this set? Total 6 elements. So the answer here will be 6. Next, what is the answer for this question? The question is saying that what is the cardinality of this set? What is the cardinality of this set? A set is given to you. What is the cardinality of this set? This is saying that x belongs to phi. But there is no x in the phi, right? See, there is no element who will satisfy this property. Correct? Do you agree? Like if I say that x belongs to, there is no such x. If I say x belongs to phi, then it simply means there is no such x, right? Okay, no such x. So if I say that, let's assume there is a set in which you have those elements who belong to phi. Okay, those elements who belong to phi, then that is your phi itself. Remember, that is empty set. Those elements belong to phi, that is empty set, because there is no element which belongs to phi, no such x. So if I say that I want those elements who will satisfy this property, okay, those elements who will satisfy this property, then there is no such element, so S will be empty set. Okay, now here you can notice that this is your cardinality of empty set. So here also I can say the cardinality of empty set, and that will be 0. What is the last question? The last question is saying that x belongs to this set. Look at this. If I say that x belongs to this set, remember this is not empty set. Please understand that this is not empty set, right? This set is not empty set. In this set you have one element. So it simply means that from here you can easily see that x is empty set, because it simply means x is empty set. X belongs to this set. So I can say here, I can say x is phi. Okay. So very simple. You can notice that what this set, the cardinality, the question is asking for cardinality of this set in which you have that element which belongs to this set. Okay, so it simply means that x is phi. Now for this set, remember, for this set the cardinality is 1. So for this question answer will be 1. I hope all your answers are correct. So the answer will be 6001. This is going to be the answer. Okay, what is the cardinality of this set? The cardinality of this set will be 1, because I am asking the cardinality of this set, and in this set there is one element, so the answer will be 1. Now let's move on. Now let's see the concept of subset. What is this concept? Subset means sub collection. Okay, subset means sub collection. I can say that, let's assume there is a collection. This is a subset of this collection. It simply means that every element that you have here, you can also find here. Every element that you have, you can also find here. Every element here, you can also find here. But some extra elements can be here. For example, you can have D, E, F, and so on. So every element that you have in this set, this is subset. Subset. Okay, subset. So I am saying that subset means that every element that you have here, that is also here. So I can say this S is subset of T. It simply means that if any element belongs to, what this means, S is this. S is a subset of T. What this means? S is sub collection of T. What this means? This means that if anything belongs to S, then it also belongs to T. But T can have extra things. In the T, you can have some extra things. But remember, S is subset. S is a sub collection. S is a subset of T. It simply means that if anything belongs to S, if any element belongs to S, then that also belongs to T. So for example, you can notice this set is a subset of this set because every element is here also. Every element is here also. Every element is here also. Okay, so easily you can see that this is a subset of this set. You can notice this is a subset of this set because in this set you have two elements B comma C. Those two are also element of this set A, B, C, D. You can note this is a subset of this set. Every set is subset of itself. Okay, of course, because every set is subset of itself because every element that you have here, that is also element here. So you can notice every set is subset of itself. You can notice set of natural number, that is subset of set of integers, and set of integers is subset of set of real number because every integer is real number, every natural number is integer. Okay, let's move on. So very easily you can see what is a proper subset. Like consider this set. You can see that this is also subset of 1 comma 2. Every set is subset of 1 comma 2. You can also see that 1 comma 2, that is not a subset of 1 because this is not a sub collection of this 1 because you can easily see this 2 is the counter example. And what is the counter example? The counter example is 2. The counter example will be x equal to 2 because you can notice x belongs to here, this 2 belongs to here, but it does not belong to here. You can notice this 1 comma 2, this is not a subset of 1 comma 3. Okay, again you can notice this counter example, the same counter example will work. So here also the counter example will be x equal to 2. Okay, so very simple. Now I want to tell you that this type of set is not a proper subset. Proper subset means that I can say S is a proper subset. When can you say S is a proper subset of T? This means proper subset. If and only if S must be subset of T and S must not be equal to T. Okay, means basically proper subset. Proper subset means this is your S, this is your T. Every element in S, that is also element in T, but there must be some extra element. Okay, there must be something extra, some extra element in T. So in this situation you will say that S is proper subset of T. Okay, so very simple. So when this is the definition of subset. Now you can also notice that these two important notes, what are those? For any set, whatever set you take, for any set S, these two things will happen. What are those? S is a subset of T. S is subset of S. Every subset, remember, please understand, any subset means every. You can take whatever set you take, that is subset of itself. And whatever set you take, empty set is subset of itself. Okay? Empty set is a subset of every set. Every set is subset of itself. These are two important results. Now let's move on. So we have seen the definition of, this is the Venn diagram. You can notice every element of A is also element of B. This is the Venn diagram of that A is subset of B. Means every element of A is also element of B. Now let's see the next definition, that is subsets. Like you can notice that for this set, how many subset you can create? For any set, how many subset I can create? In this set you have 3 elements. How many subsets you can create? So how can we create the subsets? You can notice that if you want to create a sub collection, very easy. If I give you some collection, let us assume I give you 1 comma 2. If you want to create subsets of this, S, sub collections you want to create. Subset means sub collection. Okay, so if you want to create sub collections, then what you can do? You can delete zero or more elements. So sub collections you can do. What you can do? You can delete both the elements. Just remove both the elements, you will get a sub collection, that is empty set. Okay, so this sub collection you will get. If you delete this element, you will get another sub collection, that will be this sub collection. You can notice that every element in this collection is also element in this collection. So I can say this is a subset of this set. Next you can delete this 1, then you will get another subset. So you can delete this 2, you will get another subset, that will be 1. You can notice that every element in this set, that is 1, that is also element in this set. Next, you can notice you can keep both of them. Okay, you can keep both of them. You can notice that every element here, you have two elements here, 1 comma 2. Every element here is also element here. So this is another subset. So total, how many subsets you have? 4 subsets. Okay, now let me tell you that if you make a set of all these subsets, if you make a set of all these subsets, means all these subsets, if you put in a set, all these if you put in a set, that will be called power set. Okay, that will be called power set. So this is the definition of power set. Power set means this will be called power set of S. You can denote this by P of S, power set of S, or you can denote this by 2 power S. These are the notations. Okay, so you can denote as P of S, power set. It simply means that set of all the subsets of S. Okay, you can notice this is a set which has all the subsets of S. So collection of all the subsets of S, that is your power set. So you can easily see, if your set has 3 elements, then you can create total 8 different subset you can create. Okay, this empty set is subset of every set. Every set is subset of itself. And you can notice every element of this set is also element of this set. As I told you, if you want to create subset, then you can delete 0 or more elements from this set. So from this A, I can delete 0 or more number of elements I can delete to create subset. If I delete this B, then I will get this subset. If I delete this B comma C, then I will get this subset. So total 8 subset I will get. You can notice every set is subset of itself and empty set is subset of every set. Now, how many subsets you can create? Simple question I am asking, a very important note, that if you have a set, let's assume if you have a finite set, if you have a finite set S of n elements in which you have total n elements of n elements. So if you have total n elements in the set, then how many subsets you can create? What is the number of subsets? What is the number of subsets of S? So how many subsets can we create? Tell me. You have a finite set of set of n elements. There are n elements in this set. Then how many subsets you can create? That will be 2 power n. 2 power n subsets you can create. Okay. Very easy, because for every element you have 2 choices, right? See, very easy, that if I give you a set S, let's assume I give you some set S, then when you are creating the subset, like let me give you A, B, C. Now, from this set, when you create a subset you are creating, let's assume you are creating a subset S1, then you can notice that when you create this subset, then every element has 2 choices. Okay, when you are creating this subset, then it simply means that every element has 2 choices. Every element of S has 2 choices. Either it will go to the subset or it will not go to the subset. Okay, so every element of S has 2 choices. Okay, you have 2 choices. Every element has 2 choices. For example, this A has 2 choices, this B has 2 choices, this C has 2 choices. Either you can put it or you don't put it. Okay, this B has 2 choices. Either you put it in the subset or you don't put it in the subset. So every element has 2 choices. So you can notice number of subset will be 2 into 2 into 2, that is 2 power 3. If you have 3 elements, then number of subset will be 8. And if you have n elements, then number of subset will be 2 power n. What is the number of proper subsets? What is the number of proper subsets? That will be 2 power n minus 1. Okay, it will be 2 power n minus 1. This one you are removing for S itself. Okay, for S itself you are removing this 1. Remember one thing, you tell me a simple question I am asking. If I give you a set, for example A comma B, this is a set, then tell me which is a proper subset. Which is a proper subset? A simple question I am asking. Which is a proper subset? First option, is this a proper subset? Another option, is this a proper subset? Another option, is this a proper subset? Which is a proper subset? You tell me the answer. Which is a proper subset? Proper subset of S, of course. Okay, I am asking which is a proper subset of S. So the answer will be this is a proper subset, because this is another option I can give you, like I can give you this option A comma D. Another option I can give you, that I can give you as E. So these are the options I am giving you. You tell me. So you can note this is a proper subset. It is a subset and it is not same as S. This set and this set, they are different, and you can note this is a subset. So this is not a proper subset. This is a proper subset. This is not even a subset. This is not even a subset. So remember, this is a proper subset. This phi is a proper subset. Very simple. Now let me ask you, if your set itself is phi, if your set itself is phi, then what is proper subset of S? What are the proper subsets of S? So tell me. And the fourth option, none. The fourth option is none. So tell me the answer now. So easily you can notice this is not even a subset. This is not even a subset. This is a subset, but this is not a proper subset. Okay. So this is not a proper subset. So there is no proper subset of phi. Okay. Because phi does not have any proper subset. Remember the definition? I can say S is a proper subset of T if and only if S is not equal to T and S is a subset of T. Okay. S is subset of T and S is not equal to T. So remember, this phi is not a proper subset of phi. Very simple. You can see this. Now let's move on. So what is a power set? Power set means set of all subsets of S. Okay, that is power set of S. That means set of all subsets of a set S. That is called power set. Now let's move on. Like this set, you can notice in this set you have two elements. So the proper subset, the power set will have four elements. Okay, this is your power set. In this you have all the subsets of S. These are all the subsets of S. Very simple. Now let's move on. You can see for this set, the power set will contain the set of all the subsets. So the power set will contain total 8 elements. Can you tell me what is the cardinality of power set? Another note, another important note, that if you have a set S of n elements, if you have set S of n elements, then tell me what is the cardinality of power set of S. What is the cardinality of this power set of S? That will be same as number of subsets, because in the power set every element is a subset. So that will be same as number of subsets of S, and that is same as 2 power n, that we have already seen. So in the power set every element is subset of S. So if I ask you cardinality of power set, that is the number of subset of S. So that will be 2 power n. Very easy. Now let's move on. Tell me what is the answer for this. What is the power set of phi? So remember, phi is empty set. So how many subsets are there? First of all, you find out all the subsets of this phi. How many subsets are there? The only subset is phi. For phi, the only subset is phi. So now you can find out the power set. Now you can find out the power set of phi. The power set of phi will be the collection of all the subsets of phi. This is a subset of phi, the collection of all the subset of phi. This will be the power set of phi. So remember, for this question, the answer will be set containing phi. Okay, and you can easily see that this phi, let's call it S. So the cardinality is basically 0. So the cardinality of power set of phi, that is basically 1, and that should be 1. Okay, the cardinality of power set of S, that is 2 power the cardinality of S. So you can notice here the cardinality of S is basically 0. 2 power 0 is 1. So that is correct. Okay, let's move on. Now let's see this. So what is the power set of empty set? That we have already seen. The power set of empty set will be set containing empty set. What is the power set of this? So here your set is not empty set. Here your set has one element. So in the power set there will be two elements. In the power set there will be two elements. One will be empty set. Another will be S itself. Okay, so you can easily see here the cardinality will be 2. Okay, let's move on. So these questions you can do. Okay, so this is the definition. Power set of a set is basically set of all subsets of A. So that is your power set. Now let's see set operations. How many set operations are there? We have many set operations like union, intersection, set difference, symmetric difference, set complement. See, you have operations on the numbers. So when you study the numbers, then you have some operations like addition, subtraction, multiplication, division. When you study propositions, then you have some operations like conjunction, like disjunction, conjunction, negation, implication, and so on. Similarly, for the set also you have some operations like union, intersection, difference, complement, and so on. Let me tell you what is a universal set. Universal set, the name itself is telling you universal. Universal set contains everything that is under consideration. Okay, remember, universal set contains every element that is under consideration. Every element that you consider that is under consideration, that element belongs to universal set. Of course, it will depend on the context. For example, if you study chemistry, then your universal set can be set of all the I can say elements. Basically in the chemistry. Now, similarly, if you study natural number, then universal set can be set of natural number. If you study real number, universal set can be set of real number. If you study complex number, then universal set can be set of all the complex number. So universal set contains everything. Okay, this is important. Universal set contains everything that you consider, that is under consideration. Okay, sometimes it will be given, sometimes it will not be given, sometimes it will be given. And if it is not given, then it will be clear from the question, from the context, it will be clear. Okay, so don't worry about it. But anyway, universal set, the name itself is telling you this is universal. It contains everything that is under consideration. Empty set does not contain anything. Empty set is set with no element. There is no element. Now let's see. This is a Venn diagram. You can notice that in the set A, you have 3 elements, 1, 2, 3. In the set A, this is your set A. You can notice in the diagram, this is a Venn diagram. So this is your set A, in which you have 1, 2, 3. These are the elements. This is a set B, in which you have 3 elements, 3, 4, 5. Now you can do some operations. You can easily see, if I do this, what will be this area? Can anyone tell me quickly? Some questions I am asking, you tell me. If I ask you, what is this area? What is this area? This is the area of A. Very good. Okay, this is the area of A. What is this area? Can you tell me? What is this area? Look at this area and tell me what is this area. This is the area of B. Now, what is A union B? A union B means take all the elements of A and B. Okay, this area is the A union B. So A union B is this area. All the elements of A, also all the elements of B. This is union. Intersection means common. These are the elements which are common. This is the intersection of A comma B. This is intersection. What is A minus B? Okay, set difference. What is A minus B? A minus B means only in the A. Only in the A. This area means only in the A. This area is A minus B. This area is B minus A. Only in B. Okay. And this area, A minus B union B minus A, this area is a symmetric difference. This is the symmetric difference. This area is a set difference, A minus B. This area is a set difference, B minus A. This area union this area, that is symmetric difference. Okay, so like this you can find out. So you can easily see, if I do this red color, this is the set A. You can see this red color is a set B. Okay, so very simple. Now what is union? Now let's see, if you have two set, let's assume you have set A, set B, you have two set, then what is A union B? This is the symbol for union. Okay, so this is your, I can say, this is the symbol for union. So what is A union B? In the A union B, you have those elements, you have all the elements of A comma B. You have all the elements of A comma B means you have those elements which are in A. So that all the elements of A comma B you have. So those elements which are in A, or this element can be in B. So basically take all the elements of A, take all the elements of B. Okay, take all the elements of A, take all the elements of B, take all those elements, that will be your union. Next you can notice intersection. What is intersection? What is this intersection of two set? Intersection means common elements. So those elements which are in both the set, those elements which are in both, which are common, which are in A also and which are in B also. Okay, see, you can notice those elements which are in A and B, which are common in A comma B. Intersection means common part. So this is the common part. So those elements which are in A and B. Now let's see. The next is A minus B. This is called set difference. Set difference, set minus. In this what you have? In this you have A minus B. Okay, from A you remove B, means finally it will give you those elements which are only in A. Okay, those elements which are in A but and which are not in B. Okay, so those are only in A. Those elements which are only in A, that is your set difference A minus B. So what will be B minus A? What will be B minus A? That will be those elements which are only in B, which are in B and which are not in A. Okay, so they are not in A. So that is the definition of B minus A. So very easily. Now let's see the symmetric difference. This is interesting. Let's see this symmetric difference. Symmetric difference, that is like a exclusive OR. Okay, this symmetric difference, let me tell you, the symbol is either you can use this symbol, either you can use this symbol, or you can use this symbol, exclusive OR. So this is very similar to the exclusive OR. Symmetric difference, it is very similar to the exclusive OR. Basically, if I ask you what is the symmetric difference, it will be like this. It will be A minus B only in A, union only in B. Okay, so take the union of all those elements. So what you do? Only in A, union only in B. For example, if this is A, if this is B, then you can notice only in A, union only in B. This is your symmetric difference. Okay. Now, very easily you can find this. Let me tell you, this definition will not help you much. What is symmetric difference? The best definition is this. What is the best definition? This is exclusive elements of A comma B. Okay. Set of exclusive elements of A comma B. I can say set of exclusive elements of A comma B. That is the reason you can also call it exclusive OR. Set of exclusive elements of A comma B. Exclusive elements means those elements which are only in A or those elements which are only in B. See, set of all exclusive element means only in A or only in B. So those elements which are exclusive, okay, which are exclusive elements of A comma B. So that set is called symmetric difference. So the symbol, you can use this symbol or you can use this symbol. This is the symmetric difference. Very easily you can see. Okay. Now let's move on. Another definition you can see for the symmetric difference if you want. See, the symmetric difference definition you can also see like this. This is the symmetric difference, or you can use this symbol, and this definition will be like this. You have those elements, okay, either this should happen. Either it belongs to A and it does not belong to B. Okay, either it is only in A, I can say. Either this element only belongs to A, or what happens, or this happens that it only belongs to B. X belongs to B and X does not belong to A. So either it only belongs to A or it only belongs to B. This is the definition of symmetric difference. Let's move on. Now the next definition is complement of a set. Complement of a set, as I told you, that is all the elements which are not in the set. So if you have a set S, then what is complement of this set S? Or you can say S dash, or you can say negation of S, or you can say negation of S. All these are same. Okay, so what it simply means? It simply means that all the elements which are not in the set S, all the elements which are not in the set S, so of course these are in the universal set. So let's assume you have a universal set. Universal set contains everything. Remember, let's assume you have a universal set M. Then in this situation, you can notice that it contains everything. Remember, this is the definition of universal set. Universal set contains everything. Like this is your set M. It contains every element. Okay, this universal set, it contains every element. So you can see that every set will be subset of itself, whatever set you take. So you can easily see that every set under consideration, every set, whatever set you take, that is a subset of a universal set, because universal set contains every element. So every set is subset of a universal set. Now you can easily see if this universal set contains everything. Now if you have a set S, this is your set S, let me assume this is the set S, then all the elements which are not in this set S, all these elements, this is called S complement. S complement means, I can say S complement means M minus S. Okay, all those elements, all the elements which are not in S, of course they are in M. Okay, of course, because in this universal set you have all the elements, so of course those are present in M. So this is the definition. Also, I want to tell you one very important thing, that this symbol for the set difference symbol, most of the time they will use this symbol. Either you can say that A minus B, either you can use this symbol, or you can use this symbol. So either this symbol will be used or this symbol will be used, backslash. So this symbol, remember, either you can use this symbol or you can use this symbol. Both are the symbol of set difference. Now let's move on. So you can notice this is the union of a comma b. This is the intersection of a comma b. And when can we say that two sets are disjoint? When their intersection is phi. Okay, so this is the definition. A comma b are set, and their intersection is phi. If intersection is phi, nothing is common. Intersection phi means nothing is common. Then they will be called disjoint set. Okay, so remember, if you have two set, set A and set B, and if their intersection is phi, A intersection B, if they don't have anything common, there is no element which is common. If their intersection is phi, then A comma B are disjoint. Okay, then A comma B are called disjoint. They are disjoint from each other. They are completely disjoint from each other. Okay, so this is the definition of disjoint set. So they are disjoint sets. Okay, now you tell me, simple question I am asking. What about phi comma phi? Let's assume A is phi and B is phi. Are they disjoint? Are these two disjoint? These two sets, are they disjoint? Yes, they are also disjoint. All you have to do, just apply the definition. They are disjoint because you can see A intersection B is phi. There is no element which is common in these two. Remember, in this and in this, there is no common element. We don't have any common element. So these are disjoint. Disjoint means they don't have any common element. So the definition you can apply, this is the definition of disjoint. So whenever you are in the confusion, then remember, just apply the definition that A comma B are disjoint if their intersection is phi. Okay, let's move on. You can consider these examples, like this set has 1, 2, 3, 3 elements. This set has 4, 5, 2 elements. Their intersection is phi. So these two elements are, these two sets, this set and this set are disjoint. You can notice this set and this set is not disjoint because they have some common element, at least one common element. These two, you can notice they are not disjoint, and you can notice that these two are disjoint. Okay, so here you have positive real number, and here you have real numbers less than -2. So they don't have anything common, so they are also disjoint. Let's move on. So you can see this is A minus B. This is set difference, or you can use this symbol A backslash B. This symbol also you can use. So as you can notice, this symbol also can be used. This is your definition of set difference. This is your symmetric difference. Symmetric difference means all the exclusive elements, those elements which are in A, only in A, or only in B. This is called exclusive, symmetric difference. So this is like this A minus B union B minus A. Now let's move on. So you can easily see this example. You can check it out. You have a set A in which you have 5 elements, 1, 2, 3, 4, 5. You have another set B in which you have 1, 2, 3, 4, 5, 6, 7, 8. So you can see what are the common elements. You can see A is a subset of B. You can easily see every element of A is element of B. Every element of A, element of B. Okay, every element of A is element of B. Okay, you can, from this example, you can easily see from this example that A is a subset of B. This A, this is a subset of B. This is your A. In A, whatever you have, that is also in B. Okay, every element of A is also element of B. But there are some extra elements in B. So I can say A is a proper subset of B. This A, this is a proper subset because A is not equal to B. So you can see that whenever A is subset of B, then their intersection will be A. Okay, so you can easily see their intersection is A because the common area will be this A. Now what is A union B? That will be B. What is A minus B? That will be phi. You can notice there is no element which is only in A. A minus B means all those elements which are only in A, but there is no element which is only in A. B minus A will give you these elements. These are B minus A. These elements belong to only B. They do not belong to A. They only belong to B. So this is B minus A. Now some important note you can see. Tell me some questions I am asking. You have set A comma B. Let's assume set A, set B. If A is a subset of B, if this A is subset of B, then which will be true? Some options I am giving you. Some options I am giving you, like what can you say about A union B? What can you say? Like what can you say about A union B? What can you say about A intersection B? What can you say about B minus A? What can you say about A minus B? What can you say about A symmetric difference B? And what can you say? What can you say about A A complement? What can you say about B complement? What can you say about A complement? What can you say about B complement? So these things, some questions I am asking. Tell me the answer. Quickly tell me the answer. So if A is subset of B, means this A, remember this A is a subset of B. This A, every element of A is also element of B. So this A is subset of B. Then their union will basically be same as B. Okay, all the elements A union B. So there you can notice the union will be same as B. The intersection will be same as A. The intersection, the common part will be same as A. Next, what is B minus A? That can be something. We cannot say anything about it. Yes or no? We cannot say anything about it. B minus A means those elements which are in B, not in A. So we cannot say anything about it. We can just simply say B minus A means B minus A. But what is A minus B? That is definitely phi. Okay, that will definitely be phi because there is no element which is in A but not in B. There is no element which only belongs to A. What about symmetric difference? This will be same as B minus A. Only these are the exclusive elements. Only these are the exclusive elements in A comma B. Okay, so A exclusive A symmetric difference B, that will be B minus A. We cannot say anything about B A complement because remember the universal set can be anything. Remember the universal set. The universal set can be anything. We don't know. So the A complement is simply, I can say M minus A, and the B complement is simply M minus B. Okay, so very simple. Like this you can find out. Now you can see here these two set are when can I say set equal? When can I say two set are equal? When can I say that two set are equal? This is very important because you will use this in a many questions. If you have set A comma B, then when can I say A is equal to B? These two set are exactly equal. When can I say they are equal? If and only if, see, these two set are equal means every element of A is element of B, and and every element of B is element of A. Every element of B element of A. Okay, I can say that A must be subset of B, and every element of B must be subset of A. So B must be subset of A. So I can say A is equal to B if and only if A is subset of B, means A is subset of B. Every element of A is element of B, and every element of B is element of A. Then we can say that they are equal. They are exactly equal if A is subset of B and B is a subset of A. Okay, so very simple. Now you tell me a simple question. Again, I am asking that if you have a set in which you have 1, 2, 3, and you have another set, let me assume you have 1, 1, 2, 2, 2, 3, 3, 4. Now you tell me, what about this set? Can I say they are equal? Can I say A is equal to B? Can I say they are equal? Yes or no? Yes, of course they are equal. Yes, of course they are equal because every element of A is element of B. You can notice that every element of A is element of B. Like every element of A is element of B. You can see. And every element of A element of B. And you can notice that every element of B is element of A. Like you can notice every element of B is element of A. Okay, every element of B is element of A. So you can easily see. Very easily you can see that every element of A element of B, and every element of B is element of A. So that is the reason I can say they are same. So remember A comma B are same set. So because you, so finally I can say you can remove the duplicates. In the set, duplicate does not matter. So as I told you, the cardinality of this set is 3. The cardinality of this set is also 3. So this is the definition when can I say two set are equal. This is very important that if you want to check, how to prove that some set A is a subset of set B. Okay, like how to prove this? This is very important. How to prove that A is subset of B? Let's see this. How can we prove that A is subset of B? So very simple. The proof is very simple. Just use the definition. All you have to do, just use the definition. What is the definition? What is the definition? Let's see. Just use the definition. You tell me about the definition of when can I say that A is subset of B? A is subset of B. This is the definition for this is the definition that I can say A is subset of B if and only if what will happen? This will happen that for any random element, okay, for if X belongs to A, then this x should also belong to B. Okay, this is the definition. If anything belongs to A, if any element belongs to A, if this x belongs to A, then it also belongs to B. Okay, so this is the definition of A is subset of B, where x is a random element. This x is any random element, any, I can say, random arbitrary element. This x, this is arbitrary element. So you can take a random element x, and if you can prove that if this x belongs to A, then it will also definitely belong to B, then we can say A is subset of B. This is the definition. Now, how can you prove this? Very simple. Take arbitrary element belonging to A. This is what you can do. You can take arbitrary means random. Okay, so take a random element x that belongs to A. Okay, so this is what you do. Assume, I can say you take, or I can say you assume. So this is what you do. You assume that x belongs to A. This is what you assume. Okay, then prove, then show that x also belongs to B. Okay, so very simple. If you want to prove that A is subset of B, then what you do? You assume some arbitrary random element which belongs to A. This is what you assume. You start here, and then you prove that x also belongs to B. Like this, you can prove that A is subset of B. How can you prove B is subset of A? How can you prove that B is a subset of A? B is subset of A means you take some random element in B. You take some random element in B, and then you prove that if it belongs to B, then it also belongs to A. Now, how can you prove that A is equal to B? How can you prove that A is equal to B? So there are two things you have to do. Prove A is a subset of B, and prove B is subset of A. Okay, so prove A is subset of B and B is subset of A. So this is what you can do. Or you can use the Venn diagram. Okay, so this is an important note I want to tell you. Then most of the set theory questions you can solve using Venn diagram. Okay, most of set theory questions. Most of set theory questions easily solvable using Venn diagrams. Easily solvable using Venn diagrams. So many set theory questions you can easily solve using Venn diagram. Many set theory questions. Many of, I can say most. Okay, or I can say many, whatever. So now let's move on. So as you can see, these two sets, look at these two sets. This set is equal to this set. They are definitely equal. This set is equal to this set. You can see that in this set you have 4 elements, 1, 2, 3, 4. In this set you have those elements which are integer but greater than equal to 1, less than 5. So these two sets are basically same. They are equal. So I can say A is equal to B if they are equal set. Now let's move on. So you can see that if A equal to B, if and only if A is subset of B and B is subset of A. A must be subset of B and B must be subset of A. How can you prove that X is subset of Y? How can you prove this? To prove this, you have to prove that if X belongs to X, then X also belongs to Y. Okay. Similarly, if you want to prove this, then you have to prove that if X belongs to Y, then X also belongs to X. So this is how you can do. Okay. Now let's see some set identities. These are the laws. I will not give you the proof, but these are very important. So for example, if you have universal set, let's assume your universal set is M. Let's assume you have universal set M, then some things will happen. If your universal set M, then what will happen? This M contains every element. Okay, then first of all, whatever set A you take, that will be subset of M. Okay, whatever, because this is universal set. It contains everything. This universal set contains all the elements. Every element under consideration is also there. So you can notice whatever set you take, that set will be here. Whatever another set you take, that will be here. So you can easily like this. Now, what is the second rule? The second rule is if you take A subset of A intersection M, that will be very simple. That will be A, because A is subset of M. So A intersection M, the common part will be A. If you take A union M, that will be M. If you take A minus M, that will be phi. And if you take M minus A, because M is a universal set, so that will be A complement. So these are some rules you can easily see. Okay, very easily you can notice. And remember, what is m complement? That will be phi, because universal set complement, that will be phi. And what is phi complement? That will be universal set. So these are the some rules related to the universal set. Very simple, you can easily see. These are the rules. Remember, related to the universal set, these are the rules. So if you do universal set complement, because universal set contains every element, so universal set complement will be phi, and phi complement will be universal set. So these are the some rules. Some more rules you can see, that if you do symmetric difference with m, that will be just m minus a, because m is subset of a. So that will be m minus a, because a minus m, that is phi. Okay, so exclusive, or if you do symmetric difference, if you do, then the exclusive elements are m minus a. These are the exclusive elements. Now let's see some more rules. The third rule you can notice, this associativity. This union comma intersection are associative. These are associative. What this associativity means? Associativity simply means that if you have three set, if you have a, b, c, and you do their union, then okay, you have three set a, b, c, you do their union, then it simply means that whether you do the union first like this, or whether you do like this, they are same. And we can simply say that a union b union c means take all the elements of a comma b comma c. Okay, take all the elements. So very simple. Similarly, you can notice, if you do intersection, if you have three set and you do intersection, then you can see that whether you do the intersection of this a comma b first, and then you do intersection with c, or you do intersection of b comma c, then you do intersection with a, these are basically same. And finally we will write it as a intersection b intersection c, means take all the common elements of all the three. Okay, common elements of all the three. So these are associative. Next, you can see that they are commutative. Okay, they are commutative. They are commutative. What it means, that if you do a union b, or whether you do b union a, these are same. If you do a intersection b, or you do b intersection a, they are same. Okay, so these are important. What else are commutative? What else is commutative? What other things are commutative? So let's check. First of all, you tell me what other things are commutative. Which set operations that are commutative? Set operations which are commutative. Set operations associativity, whether they are associative or not. Set operations that are associative or not. So some options I am giving you. The first option I am giving you union. The second option intersection. The third option I am giving you set difference. Fourth option I am giving you symmetric difference. So these are the some options I am giving you. Tell me, are they associative or not? Four options on your screen. Which of them are associative? Which of them are associative? So tell me. You can notice union is associative, intersection is associative, symmetric difference is not associative, and this is set difference is not associative, symmetric difference is associative. Okay, this symmetric difference, this is associative. So you can easily see that this the proof I will not give you. If you are interested in the proof, if you want to know the proof, then you can study the discrete mathematics course from the GoClasses website. Complete discrete mathematics course is freely available for all the students on the GoClasses website. So if you want to study the proof, okay, I will not go into the proof, but if you want to study the proof of everything, why symmetric difference is associative, why set difference is not associative, why these are associative, okay, if you want to study the proof of every fact, then you can study the discrete mathematics course from the GoClasses website. So anyway, so this this is the point. Now let's see the commutative. So what other operations are commutative? Let me tell you, these are commutative. Now this symmetric difference is not commutative. Remember, this a minus b, it may not be same as b minus a. They may or may not be different. A minus b may not be same as b minus a. Okay, the next point is symmetric difference is commutative. So if you have a symmetric difference b, that is same as b symmetric difference a, so that is commutative. Okay, simple. Now some questions I want to ask you. Okay, tell me, if a minus b is same as b minus a, if this a minus b, this is same as b minus a, then what can you say about A comma B? Then what can you say about A comma B? What will happen? Tell me. Can anyone tell me if A minus B is same as B minus A, this A minus B, that is same as B minus A. These are exactly same. Then what can you say? What can you say that? What will happen? The elements which are only in A and these are the elements which are only in B. See, understand, very simple. These are the elements which are only in A. These are the elements which are only in B. So if A minus B is B minus A, can I say A definitely will be equal to B? Can I say? Can I say in this situation A definitely will be equal to B? Can I say this? Tell me. Can I say A will definitely be equal to B? A will definitely be equal to B. The answer is yes. Okay. So in this situation, if A, then the answer will be this. Okay. So you can easily see definitely A will be equal to B. Why? What is the reason? The reason you can easily see that if A is not equal to B, if A is not equal to B, if this happens, okay, then this will have those elements which are exclusive of A, which are exclusive elements in A, right? These will have those elements which are exclusive in A, and these will have those elements which are exclusive in B. So of course, if they are not same, if these two sets are not same, then definitely some exclusive element will be either in A or in B. Okay. So in this situation, definitely these two cannot be same. Okay. So if this happens, then they cannot be same. They cannot be same, right? Okay. Are you getting my point? If A is not equal to B, then these exclusive elements, they cannot be same because they are different. A is different from B. It means there is at least one exclusive element. Are you getting my point? Simple question, simple thing I am saying that. I am saying that if A is not equal to B, then there will be at least one exclusive element. Okay, in this situation, if A is not equal to B, then there will be at least one exclusive element. I can say this will not be non-empty. This will not be empty. There will be at least one exclusive element. So you can easily see that I can say, so these two will definitely be different. Okay, let's move on. So you can see that this will happen, and converse will also be true. And converse is also true. So this statement I can say, what I can say? I can say that A is equal to B if and only if A minus B is equal to B minus A. Okay, I can say A is equal to B if and only if A minus B is equal to B minus A. So this statement we can say A equal to B if and only if. So if A is not equal to B, I can also say that if A is not equal to B, then A minus B is not equal to B minus A. A minus B, A is not equal to B if and only if they are not different. Okay. Now let's see this. So here you can notice that symmetric difference is commutative, but set difference is not commutative. Okay. This is one thing you can see. What is the next? So these are some properties as we have seen. Now let's see some more properties that if you do, okay. So some more properties, let's see. Some more properties. If you do intersection with phi, if you do intersection with empty set, then you will get empty set. If you do union with phi, then you will get A itself. If you remove empty set, then you will get A itself, because removing empty set means you did not remove anything. And if from empty set, if you remove set, then it will be empty set. Okay, because the complete set you are removing. Next, if you do symmetric difference with empty set, if you do symmetric difference with empty set, that will be A itself, because phi is the subset of A. Okay, so that is the reason the symmetric difference will be A itself. So these things you can easily see. And you already know that phi complement, that will be universal set. Okay, so these points you can see. Now the next point also I want to tell you that if you do A complement, then you do again complement, then that will be same as A. This is called double complementation rule. And also if you do A union A, that will not change anything. If you do A intersection A, that will not change anything. But what is A minus A? So you can notice A union A, all the elements of A, so that is all the elements of A. A intersection A, all the common elements of A comma A, that is A. If you do A minus A, that will be phi. If you do symmetric difference of A comma A, that also will be phi, because there is no exclusive element. Okay, so very simple, these points. So all these points I think we have seen. Double complementation rule. And yeah, also if you do A intersection A complement, remember they are disjoint. Okay, so they are a simple question I am asking. Tell me, if A comma A complement, can I say, is A comma A complement always disjoint? Tell me, can I say they are always disjoint? Please tell me, can I say they are always disjoint? Let me know. Can I say A comma A complement, can I say they will always be disjoint? Can I say, can I guarantee that they will always be disjoint? Can I guarantee they will always be disjoint? The answer is yes, because A intersection A complement will be phi. So they will always be disjoint, even if you take A equal to phi. If you take A equal to phi, then also no problem. Okay, then also in this situation, if you take A equal to phi, and let's assume your universal set, like whatever you do, basically your A complement will be M minus A, where M is universal set. So whatever you do, they will always be disjoint. Now, for example, a question I am asking, let's assume universal set is also phi. Let's assume universal set is also phi, and your set is also phi. Then can I say A comma A complement, are they disjoint? Are they disjoint? Tell me. If your universal set is also phi and your A is also phi, can I say they are disjoint? The answer again is yes. Just use the definition of disjoint, because you can notice in this situation A is also phi, in this situation A complement is also phi, and you can see their intersection is phi, so they are disjoint. Okay, so they are disjoint. So remember, just apply the definition of disjoint. Disjoint means, when can I say two things are disjoint? When their intersection is phi. In this situation you will say they are disjoint. Okay, let's move on. So you can easily see that if you have A intersection A complement, that will be phi. If you take A union A complement, that will be universal set. Okay, that will be universal set, because all the elements you will get. A union A complement, it will give you all the elements. Okay, so all these properties we have already seen. All the properties that we needed to see, we have checked them. Now let's see. Now let's move on. If you have any doubt, you can ask. Okay, so Manish is asking, I want to purchase your course. Is there any discount? So Manish, you can use the coupon code of you can use the referral code of any enrolled student. Okay, the enrolled students of the Go classes, they have referral code. You can use those, any of the referral code you can use, and you can get the maximum discount. So you can basically message in our Telegram group. So there is a Telegram group for the Go classes. The link you can find in the description. Let me tell you the username. The username is GATECSE underscore Go classes. So this is the Telegram group. You can join this Telegram group, and in this Telegram group you can message. Okay, you can message to the enrolled students of the Go classes. They have the referral code, and you can use those referral code to get maximum discount possible. Okay, now let's see. So the second thing, Arnab is asking A comma A complement, what is their intersection? See, Arnab, look at this. If this is your universal set, this is your set A, then this is your A complement, right? See, look at this. This is the area of A complement, and this is the area of A. Tell me, what is A intersection A complement? Tell me, what is the common? What is common? Tell me. What is the common? This is the area of A complement. What is not in A, that is A complement. What is not in A complement, that is A. So what is the common area? The common area is phi. And you can notice A union A complement, that is universal set. Okay, so very easy. You can easily see that if X belongs to A, then X does not belong to A complement, right? Similarly, if X belongs to A complement, then X does not belong to A. Similarly, if X does not belong to A complement, X does not belong to A, then X belongs to A complement. And if X does not belong to A complement, then definitely it will belong to A, right? That is the meaning of complement. This is the meaning of complement, right? So you can easily see that if X does not belong to A complement, then definitely it will belong to A. Okay, if X does not belong to, if X belongs to A, it will also, it will not belong to A complement. So very simple, like this is the definition of complement. Now let's see the next, that is distributive law. So union is distributive, union is distributive over intersection. Union is distributive over intersection, and intersection is distributive over union. This intersection, this is distributive over union. So what this means, union is distributive over intersection. It means if you do union over intersection, then what you will get? This union is distributive over intersection. This is distributive. You can distribute this union over intersection. So what you can write? You can write that A union B intersection A union C. Okay, so this is true. Means union is distributive over intersection. It simply means that A union B intersection C, that is equal to A union B intersection, A union B intersection A union C. Similarly, intersection is distributive over union. So this intersection, this is distributive over union, means it will be A intersection B union A intersection C. Again, I am not giving the proof. If you want the proof, if you want to understand the proof, you can prove it. Okay, you don't have to by heart anything. You can prove everything. If you want to study the proof, then you can watch the Go Classes Discrete Mathematics course, in which everything, every statement, every theorem, every concept, every formula is taught with proof. So in the Go Classes Discrete Mathematics course, you will never by heart anything. Everything that you will study with proof. So this is the distributive property. Now let's see De Morgan property and absorption properties. These are some important rules. Okay, very important rules. Very important rules. The first rule is De Morgan law. Means if you do A intersection B and then you do the complement, that will be same as A complement union B complement. Also, if you do A union B, then you do the complement, then that will be A complement intersection C complement. Okay, so like this is the De Morgan law. Means De Morgan law says that if you do the complement of intersection, then what will happen? It will happen union of complement of the set, like A intersection B complement, that will be, this intersection will become union, and this A will become A complement, B will become B complement. And if you have A union C complement, that will be A complement intersection C complement. Also, this is called absorption law, that if you do A union B intersection A intersection B, if you do this, then that will be same as A. See, you can prove it. This absorption law actually you can easily prove if you forget A union A intersection B. So how can you prove it? You can easily say that if this is A, if this is B, then you can notice what is this A intersection. This is A intersection B, right? This is A intersection B. Now you tell me what is A union A intersection B. Please tell me quickly. Please tell me quickly. If this is A, this is B, then this is A intersection B. Now you tell me what is A union, what is A union A intersection B. A union A intersection B, that is same as A, right? So very easily you can do. Now the same thing I can ask you. You tell me, if I ask you A union A complement intersection B. Okay, so something, so this is interesting, like A union A intersection C, that is A. Similarly, you can do another question I am asking you, and that question is something like this: A union A complement intersection B. Now what is that? Okay, did you understand the question? I am asking A union. Before that, actually, before we see this, let's see what is this one. Like, what is this A intersection B complement? So if this is A, this is B, then what is A complement intersection B? It simply means A complement. This is your A complement. A complement means this. This area is the A complement. Intersection B. Common part. Intersection means common part. Common part in B comma A intersection. Common part in B comma A intersection. That is your, yes or no? This is your B. This is B intersection A complement. So that is same as B minus A. So this is an important point actually. Okay, this is a very important point, that if you have A minus B, you can write it A intersection B complement. Okay, if you have B minus A, you can write it B intersection A complement. So this is an important point. Now let's see this. Now tell me the answer for this one. Can you tell me the answer for this one? A union A complement intersection B. We already know that this is same as B minus A. So this is set A, this is set B. Then what is A union B minus A? Remember, this is B minus A. This is B minus A. And you can notice this is A. This is A. So what is A union B minus A? That will be A union B. Okay, that will be A union B. Very simple. So this is the point I want to tell you, that A union A complement intersection B, you can easily see that that is same as A union B. Actually, this is very similar to the propositional logic. If you study in the propositional logic, there is a rule in the Boolean algebra. In the propositional logic, this is the set. This is the rule in the set theory. Now, in the propositional logic, similar rule you have, where you have like P or P bar Q. That is same as P or Q. Very similar rules you have, like P or PQ. That is same as P. So these are the rules in the propositional logic, and these are the rules in the set theory. In the set theory, what will happen? I can say A union A bar intersection B. That will be same as A union B. And similarly, A union A intersection B, that will be same as A. Okay. So like this, all these rules that you have in the propositional logic, similar rules, very similar rules you have in the set theory also. So all the rules we have seen, I hope you understood. This is a De Morgan law. You can apply the De Morgan law here. Like you have 0, 1, 0, 1 intersection 1, 2. The intersection will be 1. The complement of 1 will be 0, 2, 3. Okay. So like this, anyway, you can check it out. So all these rules we have seen, every rule. Now let's move on. So these are important rules, as I told you. A, set difference B. Okay, because this is an important rule. Like this is A, this is B. Then what will be A? What will be A minus B? This is A minus B. You can see this is A minus B. A minus B is same as A intersection with B complement. Okay, they are basically same, because what is A intersection B complement? That is common area of A comma B complement. Okay, those elements which are in A and not in B. Okay, so you can see this is the area of A intersection B complement. So this is very important rule that this happens. Okay, one more thing that happens is, if you see the symmetric difference, if you see this symmetric difference means this area union this area. This is the symmetric difference. That means A minus B union B minus A. Now that is also same as, remember, basically this is your symmetric difference. What I can do, I can say that from the union you are removing the intersection, right? From the union you are removing the intersection. Okay, from the union you have removed the intersection. So this is the point. From the union you are removing, this is the set difference. You are removing the intersection. So this is your set difference. So these are some important rules that we have seen. I hope you understood. And if you have 3 set, if you have like A, B, C 3 set, then also you can create the Venn diagram. You can create the Venn diagram like this. Like this is the union of A, B, C. This is the intersection of A, B, C, and so on. So if you have more than 3 set, then also you can create the Venn diagram. So this is the complete revision. This is the complete summary of set theory. So ultimately, I want to tell you some very important, useful rules. As I told you, like A minus B, that is same as A intersection B complement. This rule you understand. The first thing, here A, B are set. So here set is A, B. This rule is very important. Another rule that is very important is this A union A intersection B. This is your absorption rule. That is your A. You don't have to by heart, because you can easily prove it. Okay, so there is no need to by heart. Like this is A, this is B. You can easily see that this is A intersection B. Okay, so this is A intersection B. Union with A, that will be A. So this is the rule you can see. The third rule, that is A union A intersection B, A A complement intersection B, that will be same as A union B. This also you can prove using the Venn diagram. Understand that Venn diagram is very important. Many questions you can solve using the Venn diagram. In the set, whenever you study the set, for many questions, okay, for many questions, what you can do? For many questions, you can apply the Venn diagram. Venn diagram is the best and efficient method. This is the most efficient method if you use the Venn diagram. Okay, most efficient for many questions. Now let's move on. The last topic, the last thing, that is, see, you can notice that set is we represent the set like this, yes or no, and order does not matter. Set is a collection of unordered elements. So this type of thing is called set. Set is a collection. Set is a structure in which order does not matter. Remember, set is a structure in which order does not matter and also repetition does not matter. So set is a collection of unordered distinct elements. This type of structure is called set, in which order does not matter, and also in a set this does not matter, like A, B, A comma B comma A, that is same as B comma A, that is same as A comma B, that, okay, so this is the definition of set. So set is a structure in which repetition does not matter. Set is a collection of distinct elements. Okay, you can ignore the repetition, you can remove the repetition. So, and also order does not matter. So this type of structure is called set. Now there is something called sequence. In sequence, order matters, repetition also matters, and order matters. So in a sequence, order comma repetition both matters. There is something called sequence. This concept of sequence, order comma repetition both matter. Okay, both of these things matter. What it means? Sequence simply means, for example, if you have 1 1 2 2, this sequence is different from 1 1 2. This sequence is different from 2 1 1. This sequence is different from 1 1. This sequence is different from 1 2 1. So all these sequences are different. Remember, this sequence is different from this sequence. This sequence is different from this sequence. Okay, all these sequences are basically different. So in a sequence, order also matters, repetition also matters. This is an important point, the definition of sequence. So please understand that if you have this sequence, if I say you have a sequence, like as I told you, this sequence, look at this sequence ABC. This sequence is not same as BAC. This sequence is not same as B comma B comma A comma C. So these, in a sequence, all these things matter. Okay. Now, once you understand the sequence, what is the sequence? In the sequence, order matters and repetition matters. Both the things matter in a sequence. Now let's see the next concept, that is tuple. Tuple is basically a finite sequence. What is a tuple? Tuple is a finite sequence. This sequence can be finite or infinite. See, this sequence can be finite or infinite. As I told you, for example, you can take another example. Let me give another example. Like this is a sequence 1 2 3 and so on. This is the sequence of natural number. Okay, so this is a sequence, remember. So in a sequence, order matters, repetition matters. So sequence can be finite or infinite. What is a tuple? Tuple is a finite sequence. Okay, this is called tuple. Like for example, if I give you this 1 comma 1, or I can say this 1 comma 2, this is a tuple. This is different from 2 comma 1. Okay, this is called 2 tuple, because there are, in this tuple there are 2 elements. So this is called 2 tuple. Like for example, what is n tuple? What is n tuple? N tuple is something like this. You have total n elements. Remember, they can be same or different. For example, you can notice that if you have 1 1 2, this is different from 1 comma 2. Remember, this is different from 1 comma 2 comma 1. Remember, this is 3 tuple. This is a 3 tuple. This is a 2 tuple. This is a 3 tuple. Also, this 1 1 2, this is different from 1 2 1. Okay, these are different because order matters. So remember, tuple is just nothing but finite sequence. Finite sequence is called a tuple. Very simple point. Now, this 2 tuple is called ordered pair. This 2 tuple is called, what we call it? We call it ordered pair. This is called ordered pair. So what is an ordered pair? What is this ordered pair? Ordered pair is simply, I can say, like for example, A comma B, this is an ordered pair. And remember, this is different from B comma A. For example, I can say this 2 comma 1. This is different from 1 comma 2. Okay, so ordered pair. Ordered pair means two elements. So you can see this is also ordered pair. This is also ordered pair. Okay, so these are ordered pairs. Remember, this ordered pair is different from this ordered pair. So here this is 2 tuple, this is 1 tuple. So these are different. I hope all these points are clear. So what is the ordered pair? Now, when can I say two ordered pairs are same? A simple question I am asking. Tell me, if A comma B is same as B comma A, then what it means? If A comma B is, then what can you say? Then what you can say? Tell me. If two things are same, like A comma B, this ordered pair is same as B comma A, then you can notice that this A must be same as B and this B must be same as A, right? Then, or this would happen, that A must be same as B and B must be same as A. So then I can say that A will be equal to B. Okay, in this situation, A will be equal to B. Similarly, if you have, for example, if you have A comma B comma C that is equal to D comma E comma F, then what will then what it means? Then it means that it simply means A is equal to D, B is equal to E, and this C is equal to F, right? So it simply means that A is equal to D, this B is equal to E, and this C is equal to F. So this is these are some points that you can very easily understand. So what is in a set, order does not matter. In a set, order does not matter, but remember, in a sequence, order matters. Sequence can be finite or infinite. Finite sequence is called tuples. So you can notice sequence of objects is a list. Okay, of objects. This may be finite or infinite. What is a tuple? Tuple is a finite sequence. So for example, K tuple means K elements. They can be same or different. Okay. Now the last operation on set is Cartesian product. If you have two set 0, 1, 2, A, B, C, what is the Cartesian product? So if you have two set, this is the last topic. The last topic is Cartesian product. Cartesian product of two sets. It is also called cross product. You can also call it cross product. So what is cross product of two set? If you have set A, set B, these are two set, then what their cross product will be? Cross product will be a set. Remember, set the cross product also will be a set. It will also be a set in which you will have ordered pairs. The first element will come from A, the second element will come from B, because you are doing A cross B. So first element will come from A and the second element will come from B. This is the cross product. For example, if you have 0, 1, 2 cross product ABC, then you will have ordered pairs 0 comma A, this ordered pair, 0 comma B, this ordered pair, 0 comma C, this ordered pair, 1 comma A, this ordered pair, 1 comma B, this ordered pair, 1 comma C, this ordered pair, then 2 comma A, 2 comma B, 2 comma C. So you can notice that very simple. This is the definition of cross product. So if you have two set A comma B, their cross product will be set of ordered pairs. Remember, the cross product also will be a set in which you have ordered pairs, where the first element in the ordered pair, the first element is coming from A, the second element is coming from B. So this is your Cartesian product. You can easily see here, you have a set A, you have a set B, then what is the cross product? A cross B. A cross B means every element of A pair with every element of B. Every element of A pair with every element of B. So you can notice 2x, 2y. And every element of A, every element pair with every element of B. This is your A cross B. What is B cross A? If I ask you what will be B cross A? So B cross A, if I ask you that, then what that will be? So if I ask B cross A means now every element of B will pair with every element of A. Okay, every element of B that will pair with every element of A. So it will be something like this. You will have x comma 1, x comma 2, x comma 3, y comma 1, y comma 2, y comma 3. Okay, so this will be your B cross A. So this is the definition of Cartesian product. If you have A comma B, A is x, y, z, B is 1, 2, 3, then A cross B, that will be like x1, x2, x3, y1, y2, y3, Z1, Z2, Z3. This is the definition of cross product. So what is cross product of two set? If A comma B are set, then cross product is also a set. The cross product, the Cartesian product is also a set. It is also a set. Okay, it is also a set which contains ordered pairs. The first element is coming from A, the second element is coming from B. Okay, so it contains ordered pairs. Very simple. So this is the complete summary of the of our set chapter. And simple thing, finally, what the, if you have two set, a note, if A comma B, if A cardinality is n and B cardinality is m, then tell me how many ordered pairs you can create. Tell me how many ordered pairs, means what is the cardinality of A cross B? The cardinality of A cross B, what that will be? Remember the cardinality of A cross B, if you notice, this A cross B has ordered pairs, where the first element will come from A, the second element will come from B. This first element will come from A and second element will come from B. Okay, this second element will come from B. So for this first element, how many choices we have? This first element will come from A. So for this we have n choices. For the first element there are n choices. For the second element there are m choices because the second element is coming from B. Okay, so first element is coming from A, second element is coming from B. So finally, how many ordered pairs you can create? That will be n into m. So your answer will be nm. Okay, I can say n multiplied by m. So if I ask you what is the cardinality of A cross A1 cross A2 cross An, so that will be cardinality of A1 into cardinality of A2, cardinality of A3, and so on. So basically, like if you have A cardinality is m, B cardinality is n, and C cardinality is p, then what will be cardinality of A cross B cross C? That will be equal to m and p. That will be m and p. Okay, that means cardinality of A multiplied by cardinality of B multiplied by cardinality of C. Okay, so this is the complete summary. Please tell me, did we cover everything? Yes. Okay, so please tell me, did we miss anything in the set? In the basic set concept, we have seen everything: the definition of set, the operations on set, the terminology, what is power set, subset, set equality, what are the set identities, Venn diagram. Okay, everything, all the important points, all the important theorems, all the important results, the definitions, everything we have covered. Let me tell you in this session. This is the complete summary of a set. Okay, for the set, this is the complete summary. Every topic, every operation, every important thing that you need to know, that you need to revise, let me tell you, during your revision, every important thing that you need to revise, I have done that revision. Okay, so this is the complete summary of set we have seen. Now we will solve the gate questions of the set. But before that, I would like you to like this session and please comment on this session at this point of time. Okay, so all the students who are watching this video as a recorded, then please comment on this video. Okay, whenever you are watching any Go classes video, because in every Go classes lecture, whether you watch on the website or whether you watch on the YouTube channel, every Go classes video, you will always find there is a quality. This is a summary lecture, so I did not give you the proof. But remember, in the Go classes, everything we teach with proof. In the Go classes, nothing you have to by heart. There is no table, there is no formula, no theorem that you have to by heart, you have to remember. Okay, every formula, every theorem, every result, every table, every procedure, everything you can understand. You can understand with proof. Okay, so in Go classes, there is no place, I can say, there is no place for by hearting. Go classes is an institute to learn, not to rote learn. Okay, so there is no rote learning in the Go classes, and that is the reason I request you to, whenever you are watching any lecture of Go classes YouTube channel, then please give your suggestion, your review, your feedback in the comments. Okay, what did you like, what did you learn, and what improvements can be done. So basically give your feedback, give your review in the comments whenever you are watching any Go classes YouTube video. Okay, so now let's start the set theory gate questions. But before that, please like this session. Okay, and if you are watching this as a recorded lecture on the YouTube, then please comment on this session. Now we will start the gate PYQs. Okay, so let's see. And before that, I want to tell you that Discrete Mathematics complete course is freely available on the GoClasses website. The complete Discrete Mathematics, complete means all the lectures, all the topics, all the lecture notes, homework, quizzes, everything. The complete Discrete Mathematics course and the complete C programming course, these two courses are freely available on the GoClasses website. These are free for all the learners. Okay, so all you have to do, just go to GoClasses website, or you can go to GoClasses app and you can start watching, or you can find the link in the description. So check out the description, you will find the link. So this GoClasses Discrete Mathematics and GoClasses C Programming, these two courses completely freely available on the GoClasses website. All the lecture notes, homework, quizzes, everything. Okay, so let's start the questions. Now all the gate questions let's solve from the set theory. So all these questions I have taken from the GATEOverflow website. This is a website for the GATE computer science people. Best website for your GATE computer science preparation. In this website, you can find the GATE computer science previous year questions and many other questions. A lot of questions you can find for your practice with detailed solutions. Okay, now let's see. So our questions are in the set, actually all the questions are very basic questions. So let's start these questions. Tell me the answer for this question. This is a GATE 1995 question. The number of elements in the power set of S. The number of elements. The question is asking what is the number of elements in the power set PS of set S. So this we already know that if you have a set S such that its cardinality is n, then what will be cardinality of power set? That will be 2 power n. So if the set S has n elements, then the power set will have 2 power n elements, because the number of subsets will be 2 power n. So in this S, what is the cardinality of S? How many elements this set S has? So you can notice this is an element, this is an element, this is an element. Total 3 elements you have. This set S has 3 elements. Remember, in this set S, this is an element. This is an element. This is an element of S. Okay, so what is this element? This element is basically, this is the element. So you can note this element itself is a set. Similarly, this element itself is a set. So there is no problem. In set S, you have 3 elements. So finally, I can say that from here, I can say what is the cardinality, what is the number of elements in the power set? That will be number of subset of S. Number of subset of S will be 2 power 3. That will be 8. So the answer will be 8. Now let's move on. Tell me the answer for this question. This is a UGC NET question. UGC NET Computer Science 2012 question. Tell me the power set of set this. So you can notice your set that is given to you, that is set containing empty set. Please understand that this is not same as this. This is empty set. Okay, this set is empty set, but this set is not empty set. In this set you have, this is not empty. Okay, this set is not empty because there is one element. In this set there is one element. This is the element. Okay, so these two are not same. So if I ask you the cardinality of empty set, that will be 0. But if I ask you the cardinality of this set, the cardinality of this set, that will be 1. Okay, so what is the power set of this? So for this, you can notice that power set will contain all the subsets. So for this set, you only have one element. So the power set will contain all the subset. This is a subset. Empty set is subset of every set. Empty set is a subset of every set for all sets S. So you can see phi comma S itself. So the answer will be option B. Option B is the answer. You can easily check that this is a set S whose cardinality is 1. Okay, so definitely the power set cardinality will be 2. Okay, so from here you can easily see that the cardinality of power set, that will be 2. So automatically the answer will be option B. Now let's move on. Tell me the answer for this question. This is GATE 1996 question. Can you try? Don't watch this video like a movie. You can solve the questions with me. Take your copy pen and solve it. This is a GATE 1996 question. In this question, 2 sets are given to you. A, set B, two set are given to you, set A, set B, and their complements are given to you, A complement, B complement, that denote the complement of A comma B. These are the complements. Then the question is asking what is A minus B, union B minus A, union A intersection B. So this question, as I told you, most of the questions in set theory you can solve using Venn diagram. So you can create a Venn diagram. This is your set A, this is your set B, this is the set B. Then what is this set? The question is asking what is A minus B, union B minus A, union A intersection B. This is what the question is asking. So let me tell you one by one. First of all, let's see what is A minus B. First of all, let me tell you what is A minus B. The white. A minus B is this area, the white area. This is the A minus B area. Okay, let me tell you what is B minus A. Which area is B minus A? So this area is B minus A. You can notice. And finally, which area is A intersection B? This area is A intersection B. So if you take their union, if you do union of this and this, if you take the union, as you can notice, union, so this is nothing but A union B. So your answer will be A union B. You can usually solve using the Venn diagram. The answer will be A union B. Okay. So with the Venn diagram, you can easily solve this question. Okay. Now let's move on. Let's see this. This is GATE 2006 question. Can you try? This is, the question is saying that P comma Q comma R, these are set. Okay. So you have three set P, Q, R. And this is denoting the symmetric difference. This is denoting the symmetric difference. Symmetric difference means P union Q minus P intersection Q. This we already know. We already know that if you have this symmetric difference, if you notice this symmetric difference, then that is same as from the union you remove the common part. From the union you remove the intersection, because if this is your P, this is your Q, then you can easily see this area and this area, that is your P symmetric difference Q, and that is from the union you are removing the common part, you are removing the intersection. You can also say that P minus Q union Q minus P, that also you can say. Okay, and remember, this you can say P intersection Q bar union, this you can say Q intersection P bar. So that also you can say. All these are same. Now the question is saying that using Venn diagram, the question is also saying that use the Venn diagram. The question itself is saying, okay, so the question itself, this 2006, this question itself is saying that using the Venn diagram determine which of them is true. So two options are given to you. Let's see the option number 1. So the option number 1, what is that? That is P symmetric difference, and then you have Q intersection R. Okay, and the RHS, look at the RHS. RHS is P symmetric difference Q intersection P symmetric difference R. Okay, actually if you notice, this is a distributive property, right? Basically what you are doing, you are distributing this symmetric difference over intersection. So this is distributive property of symmetric difference you are distributing over intersection. So you can see P symmetric difference Q intersection R, that is equal to P symmetric difference Q intersection P symmetric difference R. This is symmetry. This is basically the distributive property, but we don't know whether this distributive property is correct or not. We don't know. We have to check whether this distribution we can do or not. We don't know. So let's check. So first of all, what you can do, you can create this Venn diagram. So let me create this Venn diagram. This is your P, this is your Q, and this is your R. These are the Venn diagram. So, and this is your universal set. This is the universal set. Now, how many areas are there in this Venn diagram? Tell me. Let me tell you how to solve this question with the best way, with the best method. Tell me how many areas are there in this Venn diagram. When you see this Venn diagram, look at this Venn diagram. How many areas do you see? When you have 3 set, right? In this Venn diagram, you have created total 3 set. So you have 3 set P, comma Q, comma R. In this Venn diagram, there are total 8 areas, right? Yes or no? So there are total 2 power 3 areas in the Venn diagram. In the Venn diagram, there are total 2 power 3 means 8 areas. Total 8 areas. Like this is your area number 1. This is your area number 2. This is your area number 3. This is your area number 4, 5, 6, 7. And this is your area number 8. So total 8 area you have. Is this clear? Total 8 area you have. Area number 1, 2, 3. Sorry, area number 1, 2, 3. Then you have area number 4, 5, 6, 7, 8. Total 8 area you have. Okay. Now you tell me, what are the areas that are covered by this? What are the areas that are covered by this? One by one I am asking. Okay. First you forget about this one. Now you tell me about this one. What are the areas that this is covering? First of all, you can notice that this Q intersection R, what area it will cover? Q intersection R. Q intersection R. This is Q intersection R. That is your 4,7 area, right? Okay. Q intersection R, that is 4,7 area, because this is Q, this is R. Look at this. Look at Q, comma R. Only look at Q, comma R. What is Q intersection R? That is 4,7. This area 4,7. Okay. Now this symmetric difference with P. Symmetric difference with P. So 4,7 symmetric difference. This area symmetric difference with P. So that is the exclusive area. Remember, this means exclusive. This means exclusive. What is P? What areas P has? P has 1, 5, 6, 7. So what are the exclusive areas? So finally, what are the exclusive areas? Tell me. This area, exclusive this area. What are the exclusive areas in these two? P has 1, 5, 6, 7. This is what P has. P 1, 5, 6, 7. And this Q intersection R, this has 4,7. What is exclusive between these two? Between these two, 4, 7, these two. What is exclusive? You can notice 1, 5, 6. This is exclusive in P. And this 4 is exclusive in Q intersection R. This is the exclusive, right? Yes or no? Do you understand the meaning of exclusive? Exclusive means exclusive, like exclusive news. Like exclusive news. What it means? Let's assume there are 2 TV channels. For example, let's assume one is like G News. Okay, whatever. Like you have one is G News, another is Aaj Tak. So there are 2 TV channels. Exclusive news means this exclusive news. It means that either G News has and Aaj Tak does not have, or Aaj Tak has and G News does not have. This is called exclusive news, right? Yes or no? So you can easily see that. Look at this P. P is 1, 5, 6, 7. This is P. Look at Q intersection R. That is 4,7. What is exclusive between these two? 4, 7. This is the news at the Aaj Tak. Aaj Tak has this news, and let's assume G News has this news. So what are the exclusive news? You can notice 1, 5, 6. This is the exclusive news to the G News, and this is the exclusive news. Sorry, this is the exclusive news to the Aaj Tak. So something like that. You can finally see this is the exclusive news. 1, 5, 6, 7. 1, 5, 6, 4. Now let's see. So this area is 1, 5, 6, 4. This is the area. Okay, let's check this one. Tell me about this one. What is the area it will have? Exclusive in P, Q. What is exclusive in P, Q? Exclusive in P, Q. Remember, exclusive in P, Q. P has what? P has 1, 5, 6, 7. Q has 2, 4, 5, 7. Okay, P has 1, 5, 6, 7. Q has 2, 4, 5, 7. What is exclusive? Tell me, what is exclusive? Exclusive is, I can say exclusive will be 1, 6. 1, 6 is exclusive. 2, 4 is exclusive. Okay, what? Similarly, this R has what? R has this area 3, 5, 6, 7. So what is exclusive? What is exclusive? Tell me. P has 1, 5, 6, 7. So what is exclusive? Exclusive will be, that will be 1, 5, 3, 4. What is intersection finally? What is intersection of these two? This and this. What is the intersection of these two? What is the common part in these two? The common part is 1, 4, right? The common part is 1, 4. So finally, this is 1, 4. Now can you tell me the answer? Now can you tell me the answer? Now very easily you can see they are not equal, right? So I can say this is subset of this. This is subset of this one, the upper one. So you can easily see this P exclusive or Q, intersection P exclusive or R. This is proper subset. This is I can say okay, or like whatever. So this is subset of this. So they are not equal. They are not equivalent. These two are not equal. These two are not equal. So remember, this is false. So this is a false. This distributive property is false. Did you understand this? Tell me, did you like this method? See, this area method, did you like? Let me know. Did you like this method? This area method? Very easily you can solve using this method very easily. Without any confusion, very easily you can solve this question. All these questions with this method. Okay, so I hope this is understood. So, so what is this option A? Actually, we have seen this option 1. Let me tell you, this is false. But what this was, option A was, this option A was saying that P symmetric difference Q intersection R, that is same as P symmetric difference Q intersection P symmetric difference R. So this is false. So this is false. What it means? So this is false. What it means? It means that I can say that symmetric difference is not distributive over intersection. So I can say this symmetric difference is not distributive. It is not distributive over intersection. Okay, symmetric difference that is not distributive over intersection. So this is what it means. So this is your option number 1. Now let's see the option number 2. The option number 2, that is something different. So let's check. So P intersection Q intersection R, that is very simple, right? Yes or no? This is simply P intersection Q intersection R. This is the common part. We have to check this. What is this? P intersection Q, symmetric difference P symmetric difference R. So let's check it out. So the second option. In the second option you have P intersection Q intersection R, that is same as P intersection Q symmetric difference P symmetric difference R. Okay, P intersection Q symmetric difference P symmetric difference R. So this is the question. This is your question number 2. Can you try this? Can you try this way? This method? This is the second part of this question. So very easily you can do. This is nothing actually. So what you can do, you can just create a Venn diagram. This Venn diagram you can create. This is your P. This is the Q. And this is the R. Okay. And this is your M. This is your universal set M. So there are how many areas you have? You have these many area. 1, 2, 3, 4, 5, 6, 7, 8 total area. So what is the area of P intersection Q intersection R? What is this area? This area is area number 7, right? Yes or no? Area number 7. So for this, the area number 7 is the okay. What about this one? Can you tell me what is the area of this one? What is the area of this one? P intersection Q. P intersection Q. The area is 5, 7. That is the intersection Q. Okay, so 5, 7, this is the area. I can say 57, I can say 5, 7, this is the area. What is the area here? Like remember, this P has what area? This P has 1, 5, 6, 7. 1, 5, 6, 7. This R has 3, 4, 6, 7. So what is the exclusive? What is the exclusive between these two? What is the exclusive between these two? This and this. What is the exclusive? The exclusive is 1, 5. Okay. 1, 5, 3, 4. This is the exclusive. Now you tell me the exclusive here. Now you tell me the exclusive here and here. What is the exclusive here and here? That exclusive will be 1347, right? Yes or no? That exclusive is 1347. So this is your exclusive. And here you only have 7. So definitely they are also not equal. And I can say this. So finally I can say that this is correct. I can say this is subset of this. This is correct. Because ultimately this area, if you look at, this will give you the area of 1347. So definitely this statement is false. So I can say that if you have this statement that this is equal to this is a false. This statement is false. Okay, so finally the answer will be that this is also false. The question is asking which is true. So the answer will be neither first comma second. The answer will be option C. Did you understand? Please tell me. This area method is very nice area, very nice method. If you have 3 set PQR, then you can create 2 power 3 areas you can create in the Venn diagram, and then you can solve any questions using these areas. You can easily solve whatever question you want to solve, you can easily solve. Now let's move on. Let's see this question. This is a GATE 2008 question. Can you try this? Don't see the question like a movie. Solve the question with me. I am also solving, you also solve. So let's see this. So very simple question again. You have 3 PQR subset of universal set U. So U is a universal set. The question has given to you, the universal set is given. That is U. And these are the subset of universal set. Now the question that is asking, then what is this set? Okay, so again you can solve this question very easily by the Venn diagram method. So what the question is saying, that there are 3 set. There is universal set M, or U is the universal set. So for a moment this U, let me call it M for a moment, so that we are not confused. This U, let's call it M. So this U, let's call it M. Okay, so I am calling it M so that we don't get confused between these two symbols. Like, see, these two symbols, they look very same. Union and universal set, these two symbols. So let me call it M. So I am calling it M. There are 3 set. There is set P, there is set Q, there is set R. So there are 3 set. So you have 3 sets. Now, what the question is asking? The question is asking this area, union this area, union this area, union this area. Okay, so let's see one by one. So very simple if you solve this question like this. First of all, P intersection Q intersection R. What is this area? Then the question is asking union. Okay, then the question is asking, what the question is asking? It is asking union P complement intersection P complement intersection Q intersection R. Okay, then question is asking union Q complement, union Q complement. Then the question is asking union R complement. Okay, so this is what the question is asking. So first of all, what is this area? Tell me. Like if I ask you what is this area will be, you can notice that this is area 1, 2, 3, 4, 5, 6, 7, 8. So what will be the final, this area? This area will be area number 7. Now the same question again I am asking. So, okay, so you can notice 1, 2, 3, 4, 5, 6, 7, 8. So tell me, this area we found, that is 7 area. What is this area? What is this one? Look at this one. What this is saying? This is saying Q and R but not P. Yes or no? Look at this. If I say like this, what this means? This means Q and R but not P. This means Q and R but not in P. Right? Okay, so you can see This is the area where Q area and R area in Q and R. It must be in Q, it must be in R, but it not in P. Okay, so you tell me what is this area? Like you must be in Q comma R, Q and R. You must be in Q and R, but you must not be in P. So that is the area number 4. Yes or no? The area number 4. Correct. So now finally, so this union will give me 7,4. This union will give me 7,4. So I got this union. This union I got, that is 7,4. This union is giving me 7,4. Okay. So 4,7 area I got. Now you tell me what further? 4, 5, 6, 7, 8. Now what is this Q complement area? Q complement, that is everything that is not in Q. Everything that is not in Q, like 1, 3, 6, everything that is not in Q. So that is 1, 3, 6, 8. This is your Q complement. Okay, Q complement will be 1, 3, 6, 8. So finally this union will give me what? This union will give me 1, 3, 4, 1, 3, 4, 6, 7, 8. Okay, so I got 1, 3, 4, 6, 7, 8. Okay, remember so far what I got 1, 3, 4, 6, 7, 8. If you see this will give me 1, 3, 4, 6, 7, 8. And what this will give me? R complement. What R complement will give me? So this R complement will give me anything which is not in R. So it will give me 1, 2, 5, 8. Finally this union will give me what? Ultimately this union, this is giving me what area? Ultimately what this union is giving me, this is giving me 1, 2, 3, 4, 5, 6, 7, 8. So I got everything. That is universal set, right? Yes or no? So ultimately I got universal set. So the answer will be option D. So this is very simple method. Please tell me, did you like this method? Let me know. Very simple. What you can do, just make the Venn diagram and you can find the area. Nothing in this question, there is nothing. All you have to do, just make the Venn diagram and find the area. Like let me create on side. Just solve the question using Venn diagram very easily. This is your Venn diagram in which you have this set, and this is your P, this is your Q, this is your R. Then what you do, you divide this in area. Like as I told you, 1, 2, 3, you can divide into 4, 5, 6, 7, 8. Okay, so now you can easily see this P and Q and R. This is area number 7. This P complement Q and R. This is means Q and R, but not in P. Q and R. Okay, means 4, 7, but not in P. So that will be 4. What is Q complement? Q complement, which anything which is not in Q, So that is this area. And what is R complement? Anything which is not in R. So that is 1 to 5, 8. Now you can do their union. This union, this union, this union. So the answer will be this. Yes or no? Very simple method. Very simple way to solve this question. Is this understood to everyone? Please tell me. Let me know. So this is how you can solve this question very simply. You can also solve the question, the same question you can also solve using the simplification method also. See, what you can do let's see the method number 2. Let's see another method for the same question. You have PQR, that is intersection, union, P complement QR, union, Q complement, union, R complement. Let's solve this question by the another method. What is the another method? Method number 2. Let's see. So first of all, you can easily see that what this will be. First you tell me what this area is. Look at this area, like PQR, union P dash or QR. What this area is? So, what you can do? You can do using this. See, here you can use a property that we have already seen. Do you remember this property that I told you that if you have A, set A, intersection A complement intersection B, this A union this. So that is same as what? That is same as A union B, right? Because this is same as B minus A. Because this is same as B minus A. So you can easily say that if this is A, if this is B, then what is this is your A union B minus A. A union B minus A. That is A union B, right? So this you can apply. This property you can apply. The same property will hold if you do this. For example, A intersection union A complement union A intersection B, that also will be A complement union B. Okay, so this is what you can do. This you can apply here. So from here you will get Q complement. Okay, so basically this Q you can remove and you will get Q complement union P intersection R. P complement intersection R. So this is what you can do. Now what you can do, as you have this union R complement and you have union PQR. Now from these two, look at from these two. From these two you can say that it will be just R complement union P complement. Okay, so it will be Q complement union PQR. Now what you can do, using these two you can remove this Q. This Q you can remove. See, this rule is actually very simple. You think like this: P union P bar Q. What you can do? Basically you can remove this P bar. Okay, basically you can remove this P bar. Similarly, P bar union PQ. Basically you can remove this P. So it will be like this. Same rule you have in the Boolean algebra also. In the Boolean algebra or in the propositional logic, same rule you have. You have the same rule. Like you have this rule, like A or A bar B. Just you can remove this simple, this you can remove. So it will be like A or B. For example, A bar or AB, you can just simply remove this A and it will become A bar or B. So very simple. This rule actually you can apply many times. So here also what you can do, you can simply remove this Q. So it will be PR or so what you will get? You will get PR union Q bar union R bar union P bar. Now you can take this and this and simply you can remove this R. So finally you will get P union Q bar or R bar union P bar. Now look at this P union P bar. This will be like universal set, union whatever. It does not matter what you have. This is the universal set. So your final answer will be universal set. So this is how you can solve this question with the simplification method. But I think that this method, Venn diagram method, is actually more powerful. So you can use the Venn diagram method. That is actually better way to solve this question. You can very easily solve this question with that method. So remember, note this is very important, it will help you very much, that A union A complement B. What you can do, you can remove this A complement. Okay, you can remove this one. So finally you will get A union B. Similarly, A complement union AB. Okay, that simply will be A complement union B. So like this. Okay, these rules will definitely help you a lot. Okay, this is my question. I wanted to ask you, like PQR union P bar QR. Can you say something about it? Can you say something about it? Like for example, this is your PQR. Look at this. This is P, this is Q, this is R, and this is the Venn diagram. For example, this is area number 1, 2, 3, 4, 5, 6, 7, 8. So tell me, what is this one? So you can notice what is PQR. PQR, that is your area number 7. That is PQR. And what is P bar QR? What is P bar QR? P bar QR means Q and R not in P. Q and R not in P. That is 4, 7. So their union basically will be 4, 7 area. Only this 4, 7 area. That means QR. Okay, that means QR. That means Q intersection R. So what I want to say, that this PQR union P bar QR, what you can do, you can write it QR. Actually, you can think like this, that you are taking QR common. you can think like this, that you are taking this QR, you are taking commons. Like similar rule you have in the Boolean algebra. In the Boolean algebra, similar rule you have, for example, ABC or ABC bar. What you can do, you can take AB outside, then it will be like C or C bar. So finally it will be AB. The same thing is happening here also. Are you getting my point? The similar thing is happening here also. If you have PQR union PQR bar, then what you can do, you can take this PQ out. Okay, you can take this PQ out. Then it will be R union R bar. It will be R union R bar. That will be universal set. This will be the universal set. Correct. So this is going to be the universal set M. Now this is the intersection, of course. Okay, there is a like this gap. This gap is the intersection. So intersection with, it's like PQ, intersection with universal set, that will be PQ. Okay, so this also you can do. I hope this point is clear. So some note, as you can see, these rules, these same rules are also in the Boolean algebra. Okay, all these same rules, as I told you, these same rules like PQR. If you have PQR union with PQR bar, then that is same as basically PQ. You can take this PQ out. You can take this outside. So it will be like PQ. Similarly, you can notice P union PQ, that will be P. Similarly, P union P bar Q, that will be P union Q. Okay, so these simple rules will definitely help you whenever you are solving the questions. Now, as I told you that in this question, what you can do, in this question, this is nothing but, if you notice, this PQR union, this is nothing but Q intersection R. Okay, union Q complement union R complement. Now you can solve this question even more easily. More easily you can solve. So you can use this way, that Q complement union QR, that will be Q complement or R. So what will happen here? From these two, you will get Q complement union R complement, and that will be your universal set. So that is your universal set if you consider this as M. So the answer will be option D. So you can solve this question in many different ways. Did you get all of them? Please tell me. Did you understand all of them? All the ways did you understand? Okay. So I hope this is clear. We have seen the set theory. And the remaining questions, already the video solutions are available. See, for the remaining set theory questions, all the remaining set theory question, the question related to set, for all the remaining questions, the video solutions are already available on the GoClasses YouTube channel. Okay, I will add those video solutions in this playlist. On the GoClasses YouTube channel, there is a playlist, Discrete Mathematics Gate PYQ. This playlist is there. Okay, you can check out. Go to the GoClasses YouTube channel. Check this playlist. There is a playlist, Gate PYQ playlist, Discrete Mathematics Gate PYQ playlist. In that playlist, I will add all the remaining video solutions of the questions related to set, because all these are already available on the GoClasses YouTube channel. Okay, for example, you can notice this is a gate question in the set theory, gate 1993 question. For this question, the video solution is already available. This detailed video solution is already available on GoClasses YouTube channel. On GoClasses YouTube channel. Okay, so you can visit the GoClasses YouTube channel and you can check it out. All the video solutions, you can check it out. So this detailed video solution is already available. Or you can go to the GATEOverflow website. You can go to this GATEOverflow website and you will find the video solution you will find. This video solution I have put, you can notice, my name is Deepak Poonia. So I have put this video solution, you can find it there. Find the detailed video solution here. So you can check it out. For example, similarly here also, this is gate question from the 1993. For this question also, as I told you, go to this website, this GATEOverflow website, go to this question, and again you will find the video solution. Again, this video solution you will find, as I told you, this detailed video solution is already given to you. This link you can find. Again, you will find on the GoClasses YouTube channel. So basically just go to Discrete Mathematics. Gate PYQ playlist on the Go Classes YouTube channel. Okay, this playlist you search. Okay, you will find this on the Go Classes YouTube channel. Okay, let's move on. So like this, many questions actually I have already solved in the Go Classes YouTube channel. Already the video solution is available. So let's solve this TIFR question. Can you tell me the answer quickly? Very quickly. The time is over, but let's see this. TIFR 2010 question. So the question is saying that you have two set. A complement is given to you, B complement, A complement is denoted like this. A minus B means all the elements which are in A but not in B. So what is A minus B? The question is asking what is A minus B. So very easily you can see if this is your A, if this is your B, then what is A minus B? This is the universal set. Then you can easily see from the A you are removing A minus B. See, this is your A minus B. Correct. Look at this. This is the A minus B area. From A you remove it. From A you remove it. So from A, this is your A. From A you remove it. So this area will be A minus B area, and that is same as A intersection B. So the answer will be A intersection B. Very simple. So the final answer for this question answer will be option D. This is the answer. Okay, so very simply you can do this, or if you want you can do like this also. For example, A minus A intersection B. If you have two set, you have only two set. There is A set, there is set B, and this is your universal set. How many areas will be there in the Venn diagram? In the Venn diagram there will be four area 1 to area 2, area 4. Now you can notice area 1 means 1, 3, and this A minus B, and this A minus B. This area, what is this area? This area A minus B. From A you remove the area of B, that is 1. So now 1, 3 minus 1, 1, 3 minus 1, that is your 3, and that is A intersection B. So the answer will be option D. Option D will be the answer for this TIFR question. This is a question from the Illinois University. This is a standard question from the Illinois University. You can try this also. Tell me, this is a multi-choice question. Can you tell me the answer? You have arbitrary set A comma B, random set A comma B. What is A minus B? Multi-choice question. Basically, this is a MSQ question. So can you tell me the answer? What A minus B is equal to? See, option A is basically, look at option A. Option A is like this. The complement of B intersection A complement, right? Yes or no? Because we already know this. We already know this, that if you do A minus B, that is same as A intersection B complement. If you do B minus A, that is same as B intersection A complement. Okay, so if I do A minus B complement, if I do A minus B complement, so that simply means that I am doing A intersection B complement whole complement, and that will be very simple. That will be A complement union B. Similarly, if I do B minus A complement, that will be what? That is going to be B complement union A. So you can easily see that this will be B complement union A. B complement union A. That is not same as A minus B, because what is A minus B? A minus B is A intersection B complement. Okay, so that is not same. So definitely this A is not answer. What about B? What about B? B is basically A intersection B complement. So yes, B is the answer. What about C? C is not answer. What about D? Yes, D is the answer. What about E? E is not answer. So the answer will be what? That will be B comma D. Yes or no? For this question, the answer will be option B, option D. So these are the answers. You can check it out. So the answer is going to be B comma D. This is another question from this is another standard question from the Illinois University, as I told you. Another standard question from the same university. Can you tell me the answer? This is the last question for this session. Please tell me the answer. With the set 1, 2, 3. This is a set given to you. Set A is given to you. 1, 2, 3. Power set is PA. Power set is PA. Which is true, which is false? So tell me, is this a, see, if something belongs to PA, then what you can say? Simple question I am asking. Tell me, let's assume you have a set A. Tell me, if something belongs to PA, then what can you say about this something? This S belongs to PA. What belongs to PA? What belongs to power set of A? Subset of A, right? So it simply means that S is subset of A. Similarly, if S is subset of A, then definitely S belongs to power set of A. Okay, because in the power set, you have subset of A. Power set is a set containing subset of A. In the power set, every element is subset of A. So if you have some element in power set, that is a subset of A. So tell me, if this belongs to power set of A, is this subset of A? Yes, of course, this is subset of A. So definitely this is correct, because you can see this is subset of A, right? This is subset of A. So this belongs to power set of A. So this is correct. This is subset of power set of A. This is not correct, because 2 is not element. It simply, what this simply means, this is a subset of PA. It simply means that 2 belongs to power set of A. But this is not true. Okay, it simply means that 3 belongs to power set of A. This is not true. So both are basically false. Okay, these two are basically false. You can easily see. So these are basically false. So finally I can say option B is not correct. Okay, what about this one? Phi belongs to PA, of course. Phi is subset of PA, yes, of course. See, very simple thing that whatever set you take, it will always happen. Okay, see, some things you can notice that. You can notice for every set, S, what will happen? This phi will be subset of S. But for every power set, what will happen? For every power set P, okay, for every power set P, this P is a power set. Maybe for some set, power set for some set. So this P is a power set. Then what will happen? Then this phi is belongs to also, because it is a power set of some set, and this phi will be subset of that, and this phi will be subset of P also. Because you can notice, see, if P is a power set, if this P is a power set, then it is a power set of some set, right? Correct? If this P, if this is power set, then for some set, I can say for some set, P is equal to PA. Correct? For some set, this P is a power set of this set A. Now you can easily see that phi is a subset of A. So it automatically means phi will belong to P. And P itself is a subset. P itself, this P itself is a set, because this itself is a set. So phi will be a subset of P. So here in this question, the answer will be ACD. The answer is going to be ACD for this question. Okay, I hope you understood all the points. This was the complete summary. We are done with the gate PYQs of set. The remaining gate PYQ are already available. The video solution of remaining gate PYQ of set, those are already available on the GoClasses YouTube channel. You can check it out. I will add all those PYQs of the set in the same playlist. Okay, in the discrete mathematics gate PYQ playlist I will add. So we are done with the gate PYQ of set. Now what you can do? First of all, I just want to tell you that this first order logic quiz is available. This is free for everyone. First order logic quiz, first order logic free test, 13 questions, 13 good quality questions. Let me tell you, all these are good quality questions. all you have to do, go to the GATEOverflow website. In the exam section, you will find this test and you can attempt. And for the last 50 days, most of the students, majority of the students, they attempt the test series in the last 2 months. So for the best test series, to evaluate yourself, to improve yourself, you can join the GATEOverflow plus Go classes combined test series. This 2-in-1 test series you can join. In this test series, you will find 15 mock tests. There are 15 mock tests, more than 100 quality tests. So for the best test series, you can join this. For the best test series of GATE Computer Science. Okay, you can enroll. The link you can find in the description, or you can go to this website. The link you will find in the description, so check out the description. For the GATE 2024 aspirants, you can join GATE 2024 complete course by Go classes. In the next 15 days, if you join, then you will get 3 months of extra access. So this extra access you will get if you join now. So don't make any late. Okay, so don't delay. You just join now and start your preparation. For the GATE 2025 aspirant, you will also get 3 months of extra access. So start your preparation now by joining GATE Computer Science complete course, GATE CSE complete course of Go classes, for the best quality learning without rote learning, no rote learning. Understand everything in depth with proof, with variations from the basics, no prerequisite. Okay. Summary lectures, homework, quality practice set, weekly quizzes, GATE question, video solutions, doubt resolution, revision practice, a lot. Okay, a lot more. So everything that you need for your complete preparation, that is available in the GATE Computer Science complete course by Go classes. You can just join it. Okay. Discrete mathematics is freely available for all the students. So you can watch it without joining. You can watch it. This is the best course for discrete mathematics. So whether you join Go classes complete course or whether you don't join, okay, you can watch this course. This discrete mathematics complete course you can watch on the Go classes website. This is the best course for the discrete mathematics without any rote learning. Everything you will study with proof. You will understand everything with proof. You can also download our Android app. You can search Go classes on the Play Store and you can download the Android app and you can watch the discrete mathematics and all the lectures. Okay. Thank you everyone. And the Telegram group, link of the Telegram group is in the description. This is the username. So you can join this Telegram group for all your doubt discussions. Technical, non-technical, all the doubts you can ask in this Telegram group. Okay. So thank you everyone. See you tomorrow. Bye. My name is Deepak Poonia and you can see. So I will teach you many subjects. I will teach you in the in this GATE 2024 complete course. As I told you, this complete course you can join. This GATE Computer Science complete course you can join. Some subject I will teach you. Some subject Sachin Mittal will teach you. You can notice both of us, we are masters from the IISc Indian Institute of Science Bangalore, and Sachin is ex-Amazon scientist and also all-India rank 33, and I have secured multiple times top rank in the GATE exam. Okay. So thank you everyone. See you tomorrow. And please like and comment on this session. Don't forget to like and comment. Okay. Whenever you are watching any video on Go Classes YouTube channel, please comment your feedback, your review, and like the session. Okay. Thank you everyone.